With that technical guidance from the state, why don't we commence our meeting? And could we move to our agenda? So first on our agenda, I think instead of doing, well, we'll say welcome to everybody who's online, and thank you to you guys who come in person for this meeting. I think one very positive announcement that we should make, sometimes a loss is actually a gain. And I think we have one of those here with Chelsea, I guess, officially leading the Expert Advisory Committee and joining the Air Resources Board. So thank you for having served on the committee and helped develop such great recommendations from last year. And we really look forward to working with you in a new and improved condition.
Thanks.
I always knew that this committee would make you happy. I just didn't know how. What is your official new title, and do you share that with folks on the committee?
Yeah, air pollution specialist, and I'll be working on SB 27 and along with other natural and working lands topics like AB 1757 with Adam.
Okay. Well, with that, why don't we do our official roll call, knowing that we are down one. So let's see. Christy, are you present? For Christy as a no. John, I can see you there.
I'm here, yes. Sorry I'm not there in person, but I'm here.
Nathaniel? Nathaniel online? Will mark is absent. Matt? Chelsea, I know you can see those lines perhaps better than I, but so Matt is not present. William? Present. Laura?
Present.
Connor?
Present.
Connor
Yes, I'm here.
And Debbie, I believe you're present.
Can you hear me? Yeah, I'm here.
And yes, we can hear you. Thank you.
Present.
Carrie is, I don't know that she is online currently. Carrie, are you online? She's planning to join us momentarily or at some point in the process. Melissa, I think you are online. And Garth?
Yep, I'm online. Good to see you all. Sorry I'm not there in person.
I'm present, and Marian.
Present.
Well, moving right along, today we are really pleased and appreciative to have several guest speakers with us, both in person and remotely, and diving into key questions around agriculture. In this, I am turning to William to lead the session. And I think with no further ado, I'm going to do that. Over to you. Here's the metaphorical gavel.
Aaron can't be here today. Can everyone hear me? I just have a little preamble before we start our talks and then go into discussions, the outcome, or some directions we'd like to take. So we are the guinea pigs. We, agriculture, land use is our first attempt at this, and so state is required under AB 1757 to validate the scoping targets that the committee is recommending to be in line with AB 32. It's an enormous task to validate the outcome of these scoping targets. It would be difficult to do using traditional sampling and analysis techniques, it would be just cost prohibitive. So we have to use some sort of other tool to predict change in carbon stocks, soil carbon stocks, for example, and emissions of greenhouse gases such as nitrous oxide. So modeling is probably the way to do that. But there are some concerns that I'll raise, and I think everyone knows my concerns knows that I can be skeptical, but I can also be of reason knowing that models have to be used, for example. So the state can choose to go modeling, which it probably will, or it could use a practice-based method, which has been implemented in other areas and regions of the world. We have, for agriculture at least, some idea what a practice-based system would look like. We have, I guess it's not a lot of data, but we have 3 long-term projects that have been completed in the state. They're all a minimum of 12 years old. One is 30 years old, or 30 years in length. They were specifically to look at different types of cropping systems, mostly row crops. They are row crops, not orchard crops, which is a problem. Orchard crops are a different beast than row crops. So, but we do have 3 long-term projects that were completed in row crops, and they mostly contain tomatoes as a primary crop. In rotation, other crops include corn, cotton, vegetables, and cover crops. Beans is another crop. Those are the wheat. Those are another crop. So we have data on that. And interestingly enough, these projects done over different temporal time spans, starting in 1988, was the first project, lasted till 2000, so that's 12 years. And then there was one started in 1994, and that lasted 30 years. It was just terminated. And then we have one that was started in 1999. It ran for 20 years. And that included a no-till component to projects. What interestingly enough, and these projects were Southern San Joaquin Valley and in this area. 2 were in this area. One, the no-till project, was in the Southern San Joaquin. The no-till experiment, as we put out in our first scoping results last October that we submitted, initially did show increases in soil carbon, particularly in the surface, but by 20 years, it showed less soil carbon than the till systems. And so time is important. So doing a 3-year project, a 5-year project, or a 10-year project may not tell you what it looks like 20 years down the road. And for sure enough, this project showed us that there was essentially no difference or loss of carbon, particularly a loss of carbon in the deeper soil, which is more worrisome in some ways, because that's the largest reservoir of carbon we have in our soils, is the deeper soil carbon. So a practice-based method versus modeling, or a combination of 2, would be an appropriate approach. Going. So the predictive tool approach, the models, there are a few of them out there. Descent is probably the more mature model. Rothc, which comes from Rothamsted in England, has been used for mainly carbon cycling. The DNDC model is also is a more mechanistic model compared to the other models. They all predict soil carbon cycling, nitrogen cycling, as well as trace gas emissions. And so those are the tools that are available to us, and the speakers will address basically Descent today. However, these models do have a large uncertainty in the prediction of carbon stocks and emissions of trace gases or greenhouse gases. This leaves us the state, at least in a conundrum, right, of using these tools to accurately predict whether or not these scoping targets have been achieved, or to what extent they are achieved. If we're going to use natural and working lands as a way to address the requirements of AB 32. I have personal experience with some of these models. My first experience with this models was with a set of experiments that aren't being done so much anymore because they're so expensive. They were called FACE experiments, acronym for free atmospheric carbon exchange. And so they were elevated CO2 experiments. They have been done in essentially a lot of different ecosystems, from forest, wetlands, marine environments, agriculture. And so they were all intended to see the effects of elevated CO2 on both plant productivity and soil processes. Most of them, particularly ours, the one I did was a forest production system in the Swiss Alps. And it did show an increase in carbon inputs from elevated CO2. And if you would plug those inputs into the model, you would get an 11-ton increase over 50 years if you could sustain that input. And most of that increase, which we've also seen in our long-term projects here, occurs in the first 5 years. So at least 50% of the increase that you'd see from change in management occurs fairly quickly in the first 5 years, 5 to 7 years. What we saw was no change in soil carbon. And all 50 FACE experiments, 50 plus FACE experiments, essentially have not seen a significant gain in soil or sediment carbon based on elevated CO2. So there's some concern because the models are kind of predicated on input. For input, more likely soil carbon will increase. So we're talking about compost, we're talking about cover crops, or any kind of waste, organic waste that would be available as a soil amendment, for example. And so the models, I've been around probably longer than I want to admit, but some of the models were based, some of the fundamental assumptions go back to, for example, 1966, Raynard Jenkinson did an elegant study with radioactive labeled ryegrass decomposition. Had a site in England, had a site in Africa, and came to the conclusion that the decomposition rate of the residue was independent of the amount. So that's what kind of drives. So the more you have, the more likely you'll end up with higher soil carbon because the decomposition rate doesn't change. So that was one of the interesting things. It's sort of a kind of like a statement that won't go away. But we know that now we know, and I'm not sure the models accurately incorporate our new observations. And what we know now is that new carbon inputs into soil, for example, can change carbon cycling in interesting ways. So new carbon inputs, for example, can increase the decomposition of older carbon. And that's called priming. And that's apparently what has happened under these elevated CO2 experiments, where you have additional carbon inputs, but no change in soil carbon, meaning that some older carbon pool in the soil was more vulnerable when you add additional carbon or different quality or types of carbon. Under elevated CO2, you do have increased root inputs, for example, root exudates, which are yummy to microbes, and maybe that's the sort of that primes the other soil pools. But I think that's one of the things missing in models is the priming effect. We don't understand the priming effect very well ourselves at the experimental level, so it'd be difficult to actually implement this into a model at this stage. Okay. Almost done. But, these models, in some circumstances, work very well. They're particularly good at predicting initial carbon stocks, which is still a little bit if at that, but they're very good at that. And so if you want to start, you want to spin up a model for 100 years, it generally gets to the right place for what your ecosystem is supposed to have. So that's a good thing. So there's reasons to believe that these models can be further parameterized, validated, and calibrated to make it even better than the initial starting point prediction. However, there's a large uncertainty, and we have to be aware that the what we propose or what we implement here are going to have to be plausible, achievable, and not a waste of resources, because we are liable to the citizens of the state of California to be sure that we are accounting for our carbon pools and our greenhouse gas emissions accurately. So I think the speakers today will address some of that, particularly uncertainty, particularly the need for more data, particularly the need for standardized databases. For example, it would be wonderful if the Air Resources Board would host a database of all soil carbon and greenhouse gas emissions research under a certain format that's available to all researchers, so that these models can be constantly updated and constantly scrutinized with data sets, for example. And things. I think that would be one of the recommendations from the speakers. So I think I'll get to the speakers. So today we have Cole.
Are you willing to take questions
Yes.
on what you have just said?
Yes, of course.
Because I think there was a lot in there that some folks might want to unpack.
Okay,
Um,
we can do that.
So are there questions online? I know I've written a few down, so I'm going to go first to people online. Are there any questions there about what William has just lined out for us?
I got a hand up.
Just from the committee members, please, to start. Matt, do you have your hand up?
Yes,
you-
I do. It was breaking up, but I just wanted to make sure I heard William correctly, that there's an issue with getting sort of clean, uncleaned, unfiltered, raw modeling data in a format that allows you to spitball different scenarios adequately. When working with CARB, there's modeling transparency issues.
Yes, I meant that.
Okay, thank you.
So,
That's
for
the same
example,
thing. Yeah.
So for example, California Department of Food and Agriculture has all these soil health projects that are completed, and they're all in report format, and they're all accessible to the public, but they would be very difficult to use as a data set. It's one of the requirements should have been for the investigators to submit to a database in the format required for doing this in future.
Just wanted to share that's the same issue we've been having with the Environmental Justice Advisory Committee and the Woods Institute at Stanford. That's why models exist, is so you can toggle the scenarios and see if, and trust that other people may have different scenarios to work out. But it hasn't been allowed. And I'm disappointed that this committee, with its expertise, is also being denied data transparency.
Thank you, Matt. Laura?
I think there are two different things here. Like, one is the availability of data from observational studies that can be used by modeling teams, whether within the state or outside of the state, to further develop, improve, and evaluate their models. And then I think the other piece that Matt's referring to is people of a variety of types having access to the model code itself and or the outputs from the model to run their own scenarios or look at the outputs directly. So and to me, they're related in the sense that they both have to do with making things more open and accessible, transparent, but they're kind of different. They're slightly different pieces, and both, I think both are worth noting.
Is there a different hand online? I can't.
John has.
John?
Yeah, thanks, Will. I was just gonna, you know, so you highlighted, I think, at least 3 different models. Are we gonna hear about those from the panels, the different, and this strengths and weaknesses, or the, you know, different aspects of the different modeling approaches from the panel?
No, I think we're going to concentrate on the DayCent model today. I'm not sure, maybe the DNDC, but definitely not the Rothsey. The Rothsey is more of a European model. We just have not embraced that in the United States.
Okay.
Mark has a question, then I have a question.
So most of what I was hearing you talk about had to do with experiments that were focused on looking at how changing inputs like increased CO2 results in changes in soil carbon. And that's important. But another thing that I think is important is thinking about changes of agricultural practices. Yes. And so, for example, in our neighborhood here, we see a lot of crop changes from annual crops to perennial crops, nut crops. And so, and what I think I heard you say, and I'd like to get a verification on this, is that there just aren't good comparative data on that.
It's been a lab since the sort of mass introduction of micro irrigation approaches, which occurred now over the last 15 years or so. And the cost of water kind of going up. There has been, you know, a significant conversion from row crops from, say, 20 years ago. Row crops were like 70% or 65% of the agriculture being done. Today, they're like 35%.
Yeah.
And so we have mostly perennial crops now.
Yeah. And I would think that'd be a major
That's a major change.
in soil carbon.
That's a major
In
change.
lots of things, yeah. But is it something that we can estimate or? No?
We have not any long-term studies.
Yeah.
That have been conducted on that. And so that's a problem.
Okay.
Conversion happens so fast that it kind of like it's a blink of an eye.
So one thing,
Yeah.
a couple of questions for you. One thing that I'm taking away is that models are perhaps capturing the boost that happens in the first 5 years and projecting that long term. Whereas what you're seeing is that over time, that gain is not necessarily sustained.
Even in our organic comparisons, you know, we have significant, you know, and the average increase is 5 tons per hectare over 10 years. And it kind of peaks at that point. It's kind of asymptotes. And you have to maintain that practice to keep it there.
Mm-hmm.
So if you change your practice at all, you're liable or prone or most likely going to lose it if it's not practice like organic.
Mm-hmm.
And so, yes. And that was one of the predictions early about Hanalali. I'm sure you know that name, and all the soil carbon textbooks that he had put out said that, you know, soil carbon sequestration is something that is viable for 10, 20, maybe 30 years, depending on where you are in the United States. But then after that, soil reaches an equilibrium, asymptotes carbon content, but the management needs to be done in forever to maintain it that way.
That's a really interesting tie to something that actually, when Chelsea was a member of the committee, that we also talked about, which is that, and it's one of our key recommendations, and I'm saying this in particular to Amanda, is the linkage of the short term and the long term.
Right.
And so if we're looking at a transition to organic agriculture, then we need something like a conservation easement that says it's going to stay in organic agriculture, or you're going to have to decline down that carbon.
Because for inventory purposes.
Yeah. So I think that's a really excellent example of why we link short term and long term. And don't bank on the short term to obtain for the long term unless you've anchored that. Or we'll be fooling ourselves and we'll be right in the middle of peak carbon and releasing more. That's one thing. Second was you talked to us about the face issue with why that did not maintain. Do you have any thoughts or observations about why the no-till ended up being a decline?
Yeah, because that was somewhat surprising because it followed the textbook for about 12 to 14 years, and then it reversed and it lost carbon over time. And I really don't have an explanation for that. Yeah, no-till is a system that was developed for arid environments, basically to conserve water. And it worked well. You could, instead of growing a crop every other year, to try to build up soil water, no-till allowed you to grow a crop every year. But there's benefits to no-till besides sequestering carbon. Inputting carbon into the surface changes soil qualities, soil health, increases infiltration, increases microbial diversity. So there's other reasons to do it than think about when you think about soil carbon. That's just one aspect of it. But there's so many more aspects of adding amendments, doing reduced tillage or conservation till that are very beneficial to soil health, that have an effect on greenhouse gas emissions, for example, water use or things like that. So, yeah.
I hope that our panelists will get to this integration of both practice-based and modeling combined, just given the challenges of the scale of the state and trying to do things the state-wide data. Thank you.
Right. Is that it?
Yes.
Okay. So we have today we have Cole Smith. He's got two personalities. He's a staff research associate, right, with Ag and Natural Resources, the UC system. He's also a graduate student, getting his PhD, working on these issues. We have Steve Del Grosso. He's from the USDA ARS in Fort Collins. He's kind of a mastermind behind the DayCent model. Chris Covey. I don't know too much about you, Chris, but I know you've done a lot with these issues, and so this group will tell us what they know, what their opinions, and what directions we should go. So I think what we're going to do is we're going to go with Chris first, then Cole, then Steve. Chris, are you ready to go first?
Yeah, that sounds great. Okay, if I share some slides.
Yeah.
We're gonna need to share them from our end just for the permissions.
Okay, I think that'll be all right.
But
I had a video in there, but I'll do without it. It doesn't matter much.
So I'll share it and then you can just tell me in advance, Chris.
That'd be great. There's going to be a lot of that. I'll hammer through. So I guess to introduce myself, I'm Chris Covey. I also wear a couple of hats. I'm an assistant professor of environmental studies and sciences at Skidmore College. I think it says Michigan State on the agenda slide, and I guess that's probably from my co-founder of the Soil Inventory Project, a gentleman named Bruno Basso, who built the SALIS model and is working on a multi-model ensemble effort for ag right now. And I'm also the co-founder and president of this nonprofit organization called the Soil Inventory Project, where we're trying to build a national soil inventory system using a sort of novel combination of existing technologies. So how do we sort of think about it as a 23andMe for soil. So we send out kits in the mail to collect soil information that's supported by a web dashboard where we collect landowner information like parcel boundaries, and then provide automated sampling design and reporting and things like that provide value to landowners. We then bring those soil samples through a traditional lab process, and then we hand those off to the modeling team in Bruno's lab at MSU to model. And I'd love to talk about both of those efforts. And at the risk of this looking like a TSIP commercial. I think what I'm going to say is that I'm going to show you what we're doing in thinking about doing inventory at scale, because we think this is a good way to do it. And so if I were giving advice to a panel that was trying to sort of count soil carbon at the scale of something as big as California, I would say that it would be nice to use an integrated system that collects, the kind of sort of deep studies that you all were just talking about, the idea that you would be in one place for a long period of time, really getting this process-based understanding, testing principles at, intensively at fine scale. That's one thing you need. Then you need to capture the sort of variability across the landscape in both space and time through measurements, and then use both of those things to parameterize and initialize and verify a modeling approach. And that as much of that as possible needs to happen out in the open. And what I mean by that is that the data needs to be out in the open, and then the models need to be peer reviewed and published. And so all of that is really important. And then I'm going to talk about a couple of the products that we're building regionally that I think make those models much more valuable to producers in terms of giving them the insights that they need to manage for the things that we're talking about managing for, and all of the folks that then go up supply chain from the producer. And so trying to provide the value with the inventory, right? Because if an inventory costs more than it's worth less than nothing. So trying to get that price of inventory and modeling down so that we can actually gain insight with it at scale. And so we can bomb through these slides here. So maybe next slide. So I just want to say just quickly that when I say we in this, I'm talking about a whole team and a lot of young people that have gone into this, and I'll show a couple other pictures, but with the idea that the system we're building, the only thing you need to run this is the ability to run a smartphone and a drill. And with our students, the challenge is usually the drill, and with the producers out in the field, it's usually the smartphone, but we're working on both sides of that at once. So skip to the next. So again, I said we're a nonprofit building this to be held in the public trust. I think that's really important that that you have data held in the public trust. I would love to see this as a government program. We have bumped into some problems with producers' willingness to share private information with government entities. We've also held or bumped into problems with large companies giving data over to the government. And so we're kind of sitting in this middle ground between a lot of for-profit institutions, a lot of government institutions, and trying to be a sort of trusted nonprofit science-led partner. And a big part of what we're trying to do is build regional baselines. And I'm going to talk about why those modeled regional baselines are super important, or at least from my opinion, are super important. And then with the goal of linking practices to outcomes. And so understanding that when we do one thing, we get something else. So next slide. I'll actually just skip over this. I think given what we saw or what we just talked about, just the idea that folks are starting to do these plans, it's happening. And then let's talk about why this is all happening. Here's the mental model we've all been working under, right? That we're going to make some management change. There's going to be some period of time, and then we're going to see an increase of near surface carbon, and that's going to be linked to all of these wonderful things. This is a story that we tell ourselves, and I think just click through these pretty quickly as we build the rest of this diagram, and I'll just talk over it. So of course, as we build the soil carbon, we're going to get better aggregation and infiltration, and then we're going to improve our water and nutrient holding capacity, right? So we're going to need less fertilizer, and then of course, because that fertilizers and washing out into our streams, we're gonna have all these wonderful benefits. And then at the end of it, because we're holding on to our water and our nutrient, we're gonna have better yields and yield stability. We're gonna ride out drought. And of course, the fundamental problem with this, right, is that whereas we have this set of site-specific case studies, we don't have good systems for measuring near surface soil carbon at scale. And so we keep telling this story over and over again based on individual case studies. But the challenge isn't, does this work or doesn't this work? It's how well does it work? where and at what cost, right? And so you really need to be able to measure soil carbon at management relevant scales. If you're going to put it on a farm balance sheet, if you're going to provide incentives for folks to take on management change, which is then going to add up to the impacts that you're looking for at scale, right? And so that all comes together into recognizing that you have to be able to measure soil carbon in a meaningful way. Can be modeled, but measure and modeling it in a combined, ideally in an integrated system. And we'll talk about what that looks like. Next slide. While we're figuring this out, this is exactly the challenge, right? So here's a report from Rodale. So there's a global annual CO2 emissions on the left. Wow, big bar. Oh, but look at the potential of regenerative agriculture. Don't worry, it's going to fix it. Next slide. Another reputable tank. Here's a headline from World Resources Institute: regenerative agriculture, good for soil health, but limited potential to mitigate climate change. That seems like a completely different answer. Next slide. And then TNC with its Natural Climate Solutions Project, and this from Griscombe et al., right? Okay, it's a really good lever, but it's not the best lever, it's not the worst lever, it's one of the wedges in the mix. And how do we get to all these different places? It's because we really have a hard time measuring it, not in individual places, but all over, and understanding at scale how this adds up. We really have pretty limited information, and we're looking essentially at different data sets. Next slide. While we're figuring that out, all these people are selling carbon credits through the voluntary market. They're providing growers with insights about how to produce more carbon. They're selling these insights through supply chains up to scope 3. And so there's all kinds of trading and action going on. And we're running this risk of getting out over our skis and losing a lot of our credibility and the lever that ag could be in some places for a whole lot of positive outcomes, because we haven't really built integrated inventory and modeling systems for this system. Next. So this is where we came in. I had the good fortune to be asked to come down to Al Gore's family farm, Caney Fork Farm in Carthage, Tennessee, and work with their land managers on looking at their impact of regenerative practices. Again, one of these sites doing really interesting work, there are tons of them, and saying, let's use our work to represent larger scale. And I met Bruno there, and Bruno said, well, what are you working on? And I said, well, I'm thinking about how to get low-cost geolocated dirt in a bag. How do I get a lot of soil samples from a big area at low cost? And I said, what do you do? And he said, well, I build these really big scale models. And I said, well, I could really use your modeling expertise. And he said, well, I could really use all your geolocated dirt in a bag. Let's start something. Mr. Gore was really excited about that idea, and the idea that we could bring the insights that we were getting on his farm and make them more freely available. So we put together this team and spun up TSIP to kind of do just that. So next slide. And the idea is that we're going to take that diagram, that story we were just telling you all, and put numbers on this, right? With the understanding that we need management relevant information at small scales, and that's going to support getting the larger scale inference, or the ability to feed these models at larger scale, right? Next step. And so what do we do? So we do these field campaigns, the sort of 23andMe for soil. And the reason we started doing this is because we were sending folks out into the field, classic technician style inventory, pay someone to head out and get your geolocated dirt in a bag. And what we realized was that we were spending almost 70 cents of every inventory dollar was being spent on a rental car, a hotel room, an airplane ticket, meals for that technician, conversations with a producer about a gate code or how to access a field, or, oh, I sprayed that field, you can't, please come back tomorrow because I just sprayed in there. And that was really driving up inventory cost. And mainly what we were trying to do was get geolocated dirt in a bag from a known depth and a known location, and generally a location that the farmer just was yesterday, right? Because they were either out there spraying, or they knew that you couldn't get in that gate, or the road was washed out because they just drove over it yesterday. And so if we could build a system that they could get really quickly, then we could get lots of relatively low quality data, right? Compared with a meter deep core or these deep time studies, these are relatively low quality data, but what they give you is a picture of landscape scale variability that you can then use to, again, to initialize a model or to see how that model is really performing in space and time against an actual set of field measurements. So we built this, we built sets of low cost field tools, and click to the next slide. And then the next thing that we do is we use those to feed cutting edge models. And I think we're going to hear about Dayscent. My colleague Bruno built another, we'll call them a competitor model, SALIS. It's kind of silly. They're not really competitors, right? You're building different models that these process-based models is, and I'm not a modeler, but with my limited understanding, what I can tell you is that these process-based models largely favor one thing or another, right? They say, we're going to look at this aspect of what drives the system, and we're going to weight that because I think it's really important in the system that I'm studying or in the data set that I'm using to build my model. It appears as a really important process to favor, right? And then one model will favor another or be more finely tuned for a specific location. And in the same way that we have multiple global climate models, and then we bring those together into an ensemble approach where you produce, a number of different possible futures from each of the models and then bring out a mean trend line. Bruno right now is in his lab running all of these big global ag models. I think he's now running 7 or 8 with a target of being up over a dozen in the coming year. I think this is going to be a big, exciting paper when he puts it out, with the idea that we should be using this wisdom of crowds approach for modeling agricultural systems in the same way that we do for the climate system, right? And that should be initialized and verified with field data so that we can monitor how well that's performing over time, but be able to give insights as we go and adapt the model over time as well. So next slide. We also break a lot of stuff. So I said field hardware, I'm going to kind of zoom in on what we do with that. So we were using push probes. It was really lousy. It's not fun and it's slow. So we started building these auger-based extractors. So I'll go next slide. With a stop, we break a lot of stops too to control depth. Next slide. And we've been through a lot of these. And so we've got now a settled system, and we actually offer these for sale, a nonprofit for sale, but that funds the work that we do. Next step. This is a video that I won't show you, but I'll tell you what was here. And that is that this is a vineyard in Sonoma in the middle of the drought in maybe, I guess that was 2021, maybe 2. It was sort of the tail end of your bad drought. This soil was locked up like a stone. And so we actually built a new extractor that runs off a masonry bit and can get into the soil at any time. It takes about 1 minute to geolocate a bag and scan 2 soil samples, one from 0 to 15 centimeters and another from 15 to 30 centimeters. And so we get a set of stratified samples, and that takes about 1 minute. I'll show you the results from this study here in a hot second. Next slide. So this is the package that we put together, and this is an image from we just published last year. The associate director of TSIP, Dr. Kelsey Jensen, published a paper showing that the auger system that we're using produces the same result as a push probe, and in upstate New York, that it's about 2 to 3 times as fast and gets you a similar estimate. I think if you were dealing with hard clay soils in California, it's infinitely faster because you can actually get the sample. So next slide. Next slide. I'll skip. That's the full package with the QR coded bags and the whole bit. What's needed to send out into the mail, a drill and the kit. And then we make these beautiful maps, right? So we take these high resolution inventories, and largely the way that we've been building the system is we go to these places where we can afford to take a lot of samples. So massively oversample, with the idea that we need to get one of the fundamental questions that we've been working on is how many samples do you need and how do you throw them out on the landscape so that you can get an efficient inventory. So next slide. So basically what we did was we took those inventories where we've got massive oversampling, looked at different places. We were looking through the literature and you see, oh, just put down a grid. Oh, no, don't do a grid. You want to stratify your sample. Oh, you want to stratify your sample using, this method. Oh, no, you want to stratify on these variables. No, you want to use conditioned Latin hypercube sampling. So what we did was we got a sample density where we could look back and say what actually is the quickest, cheapest way to put down these samples. And so we looked back and we did a series of like a post hoc virtual samples where we grabbed the sample that was going to be closest to that predicted design. We then looped through that process, hundreds and thousands of times to get to see what would have been the most efficient sample. And then next slide. Basically what we learned is there's no way that was the best everywhere. And I think this, like the modeling answer, this sort of sampling allocation, the stratification answer is the same, which is that it really depends on where you're asking the question, which one was the best. But what we did find was that there were some ways that were clearly the worst. And so we should be avoiding those when we go out and take samples. And there were a couple of ways that were pretty good all the time, depending on what you were trying to get at. So for example, CLHS, powered by the Polaris prior carbon prediction, which is a big geospatial data layer, works pretty well to get you a decent sample no matter where you're sampling. And so we use that a lot. And then grids actually don't perform that poorly relative to some mistakes you could make. And they do make pretty maps. And although those pretty maps are largely useless, landowners tend to like them. And there's actually a lot of utility in having landowners like the thing that you're giving them when they're doing the inventory, right? So next slide. So I mentioned this mobile application, but we basically built this to have a web dashboard that onboards growers. They delineate their field boundaries. They put in management relevant information. In some cases, that's because we're paying them to do it through a large USDA grant for climate smart commodities production, or it's because they're part of an aggregated network of growers, right? They're selling milk to Stonyfield, right? Or they are, you could think of an almond producer or a citrus producer, which is, where they're selling into larger organizations. There's a lot of their product flowing to one producer. And so either they're putting in the data or that aggregator is entering the data. And then we take that data, we use those sampling design processes. We build code to automate that, right? To get rid of the expensive part of doing sampling design. As soon as you're talking to a grower about how to do sampling design, you've lost, right? So here is the design that brings their smartphone, lets them know the design is ready. They can walk out into the field, use that very fast field hardware to collect the sample, get it into located QR coded bag that then moves through that lab process and gets fed out to the modeling team so that we can provide the grower with insights and then also use that data at scale to understand how well our models are performing. And then I'll get to the high value piece of the modeling approach, from my opinion. Next step. So I just wanted to show, we've done some campaigns in California with this system and are building inventory systems, for example, for wine grapes. And it's really interesting. This is really important to build different systems, right? Inventory in a grassland grazing context looks very different than specialty row crops, where the management is so intensive and fine scale, right? So the vine row versus the tractor row can make a really big difference in what you're seeing. And thinking about how you're inventorying that entire system, understanding that is important. So again, we did these very high resolution samples within that. Next step. And we make these pretty maps, right? Again, these high resolution maps. And largely, I want to stress, largely these maps are not useful, except for potentially one, asking questions like this in that bottom map. It turns out that hotspot pumps a bunch of grapes into their high value bottles. And so they said, wait, that's interesting, right? And I think this is one of the things that we lose sight of in this carbon conversation, is this difference between folks who are going to be growing carbon, if you will, to sell to a carbon offset market, the needs of a state and accounting for its emission targets, folks who are not going to receive an additional payment, but that carbon sort of check mark certification accounting is going to flow up supply chain for scope 3, right? So you think about your big corn, wheat, and soy operation in the Midwest. I don't think they're going to be selling a carbon offset credit. I think that's going to end up as a climate smart claim on a cereal box, and it's going to be about either market access or well, largely about market access. And then you've got some folks like Jackson Family Wines, who've been an excellent partner, and now we're partnering with International Wines for Climate Action as well on that large USDA project. And these are relatively low productivity systems with relatively slow sequestration rates, and their businesses have large carbon footprints, right? So why are they looking at this? They're trying to offset glass production, right? Glass is super carbon intensive. And then they're flying winemakers on planes, right? And things like this is really carbon intensive. But these systems have really low carbon sequestration rates. So you have a hard time sinking a lot of carbon into them. Even in a world with a $200 ton, which fantasy, the amount of money that they would pull down in a year from a carbon offset credit is rounding error on the value of these really high value specialty crops like grapes or citrus or almonds or something like that, right? So why are they doing it? Well, now we're getting into a place where the water is the key consideration, right? Or nutrient use efficiency or crop quality. And can you relate that to the carbon in the soil? And that becomes the driver of why they're motivated to do inventory. And I think we see them really looking to move forward with this project over time, doing more continual inventory, right? And finding a way to have folks energized to take this inventory, and then having that data come into a central place is what's going to get you those modeling results that you really want in a way that produces insights that are valuable at aggregate. Next slide. Same with solar sites. I don't know if you all have been bumping into this, but we've been working with National Renewable Energy Laboratory, DOE, Argonne National Labs on building a repository for soil data related to solar sites. And a lot of that driven by agrivoltaics, which I think, again, in the dry American West are going to be really important as you're providing shade for crops, increasing water use efficiency, increasing yields, and at the same time, potentially building carbon. And so how do you account for that? And it turns out a solar site looks an awful lot like a vineyard when you look at it from space. And so trying to use the lessons from inventorying and modeling both kinds to inform future work. Next step. And the next thing we've been thinking about is how do we get rapid bulk density and distributed bulk density and soil health data, right? And the bulk density, because we need to get to stocks. And so you need a defined volume of soil, but the current tools are expensive. You can't put them in the mail. And so you get right back into that problem. So we've piloted this system on a number of farms last year and are going to be putting this out again this summer for the ability to put out tubes in the mail that can collect known volumes of soil. And so we're using this thin-walled, really low cost, like $4 a piece, aluminized steel pipe that you can just pound in, cap, stick a QR code on, scan right in the field again, and get it out to the lab. And at the same time, the soil health, you don't think of it, you're like, oh, well, is that really the carbon quest? Is that really, we started out just doing carbon. The reason we've expanded into soil health is because, again, if you want producers to give you the data that you want to get the end goal that you're headed towards, you need to give them some kind of incentive. And a lot of them are already measuring things like fertility or interested in soil health scores. And the same thing moving up supply chain. A lot of the folks who are going to pay for your inventory are interested in soil health as much as they're interested in carbon, and they're interested in the relationship between the two. And so if you can build a system that's low cost to get one, you can get the other at low cost, relatively free. They're already paying for some of these samples. And if you could piggyback onto that sample, then you get a campaign that can really reduce costs. Next step. And we're breaking a lot of that stuff now. I think we can skip through probably a couple of these. Let's see how this goes. Sorry, I thought I'd be poking. It's much faster. That's just a broken, really expensive tool and a broken, cheap tool. And lots of broken, cheap tools with the idea that breaking things is our really the thing we're best at. Next. Except for students, we don't break them. And that we're working in all kinds of different environments. Next one. And the next. this is so then once folks are out like piloting this equipment, getting the data, we're then coming in and we've been building these reports, and we started out building these completely manually for landowners, and by landowners I mean individual farmers, organizations like solar companies or National Renewable Lab, or land investments as conservation equity partners, right? And then sending them and saying, here's some information, what do you think of this? And largely they say, what do I do with this? And I say, nothing, it's useless. Out of context, this information is completely useless. What do you think of the figures? How does this look? How is conveying this information work? And we've been getting this into a format where they can look at it, understand what they're seeing, and then we've been automating these reports so that we can produce them at scale. Again, the idea that you get all the expensive parts of the system out and start to build a system that provides value to the people who are going to be getting you data. And so I said that was useless. And the reason that I say that it's useless is because out of context, this timestamp is largely useless to a grower, and it's largely useless to a supply chain as well, right? I say your soil carbon stock is 4, whatever, it doesn't matter, the number 4. What does that mean? Is it going up? Is it going down? How does it compare to my neighbors? Is it more because I adopted this practice, or is it just more because it rained all last year? It rained all night and it was sunny all day and my crops grew really well and I built carbon, right? Did I lose carbon because there were 4 years of drought at the end of my study? I don't know. And the only way to know is to compare site-specific data to larger regional patterns, right? So next slide. So I meant to say at the beginning of this because it's super important. I'm not a soil scientist. I've never studied soil scientists. I'm not a soil scientist. I'm a forester. And I got sucked into soil science because we had done a project where we used ground source plot data and large geospatial models to extrapolate out the number of trees on Earth. And then my colleagues and I were working in a research program within Yale that was tasked with helping private land managers in the American West better manage private lands, and which is again ridiculous. And so we just said, well, we're good at counting stuff. What can we count for you? And they said, count soil carbon for us. So we went out and we started measuring soil carbon all these various ways. And as a forester, I started to look around and be like, where is all of the large scale data that the U.S. Forest Service gathers for foresters to better understand how forests work? And I mean that as in forest land managers, but also in terms of markets that support forestry. And so if you look at the success of the forest carbon market, it's largely based on the fact that the U.S. Forest Service has been working on forest inventory for a couple hundred years and really intensively producing large scale forest inventory since around the 30s, right? And building models that allow you to throw a DBH tape around a tree and then very quickly say how much carbon we think is in that tree by species, by location, and then building these regional baselines, right? These groups, these FIA supersections where you're saying the inventory within this box on average is about this. And this is a coarse map of these supersections. You can actually go down in within these sections and say, if it's spruce fir in this section, then the average carbon stock is this. And that lets you compare the inventory that you just got. When I go out and do an inventory, I can look and say, how does it compare to my neighbors? Do I have a lot of standing volume or a little bit of standing volume? Which species are associated with high standing volumes, right? And so you can start to get at how management is going to interact with the outcome. And this is what we need. This is what we need for soil carbon. And so this is what we're trying to build, right, is a set of regional practice baselines modeled off of the data so that when a grower took a set of soil samples across their property, you could say your carbon is higher or lower than others in your same biophysical region. Folks who had the same potential to sequester carbon have less carbon than you do. It may be linked to the fact that you're doing these practices. And because you'd be able to update those models on an annual basis, those regional practice baselines on an annual basis, you'd be able to say, hey, your whole region went up last year because again, it was raining all day, or it was raining all night and it was sunny all day. So your whole region gained carbon, but did you gain more than the average? Or in a really bad drought year, did you hold on to more than the average? What did that look like on net? And so start to get at some of the practices and start to get at a place where you could give people valuable information from a single time stamp of data. Next slide. I talked about some of this stuff, but I think even within the state of California, thinking about this system or whatever inventory and modeling system you're building in the same way that we're trying to think about it at TCIP. And that is that there are very different reasons why growers are interested in this information. And again, I think you're interested in why growers are interested because you want them to provide you with the data that you need or provide the modelers with the data that they need. And so they need to be incentivized. And also because we need to understand that carbon isn't just about the emissions that we're producing, but there's a whole lot of value that comes from the resilience and adaptation aspects of building carbon, particularly in a state like California, particularly in light of your groundwater management legislation that's going to come online in the Central Valley, right? And so looking at these, we put together 3 groups for this project. One group, small farmers, relatively smallholder farmers on the East Coast. So Glenwood Center for Food and Ag or Food and Farming, and Nature for Justice down in the Southeast. And these are smallholder farms, diversified crops. They're not going to produce a lot of carbon from a market perspective, but potentially from a marketing perspective, because they're already selling those sort of like soil health, organic values, and is climate smart part of that value set. In the middle US, partnering with Bayer, 100,000 acres of corn, wheat, and soy through their carbon program. And again, these are folks who may or may not be entering an offset program, but are certainly need to start tracking their carbon levels in their soil because someone upstream has made a Scope 3 claim, right? And so PepsiCo or Yum Brands, whatever, has made a climate goal. And so they've turned to a Bayer or a Cargill, a Corteva, and said, hey, we can't buy that starting 2025 or starting 2030. We can't buy that unless you have a stamp. Get us something. And so then that gets pushed down to the grower. I can't purchase unless you have some kind of inventory or some kind of modeling approach that's going to verify that you are climate smart or regenerative, right? Or both. And then you get out into California again, and this is Jackson Family Wines, International Wines for Climate Action. And I think this is largely going to be an area with these specialty row crop growers where we're talking about either social license to operate through something like the SGMA program or SGMA legislation, or looking at things like water use efficiency in times of increasing drought, right? And can you be resilient? And so I don't actually care about the 1/10 of a ton an acre or 1/10 of a ton per acre per year carbon gain, but I do care if my irrigation well is dry and I need to ride that out, right? So I think within the state of California, thinking about how the modeling exercise that you're going to go through, the inventory exercise that you're going to go through is feeding all of those values, is going to help generate the data and the public interest in the program moving forward. I think maybe there's one more. Yeah, so the last thing, I just kind of a summary slide, and that is that I do think that you need to collect field data. I heard a lot about models. Models are incredibly important. You cannot do inventory at scale without models, but you cannot build reliable models and have them be trusted unless you are also collecting field data to support those models. Those data need to be publicly available, and you need transparent model development. I see a whole lot of proprietary business models being spun up. And of course, the challenge with that is that when they are proprietary and built around proprietary data sets, they create an illusion that soil data has value. And the reality is that it's the ecosystem services that come from these systems that have value. And the data is what allows you to access the value which is being provided by a producer. And so anytime you're transferring value from that producer and those ecosystem services over to a proprietary data set, you're essentially limiting your potential to implement practices, because that's money that did not go to the producer to adopt the practice. And so you either have producers who are less incentivized, or you have the same incentive payment that could be made out over a larger number of acres and could add up potentially to a larger impact. And so those publicly available data sets are so important. The last thing that makes that so important is that what markets want out of this, and so the incentive, again, to have these actions take place on the ground is trust. The entire value of the system is in how well you believe these actions have a given result. Whatever system you build must be trusted, and it must incentivize incentivize, or well, I should say disincentivize the construction of systems that are not going to be trusted, because that's going to create problems in the long run for producers and for regulators up through. And then this idea that we should get to these regional practice baselines, and that those are so tremendously valuable in terms of catalyzing rapid adoption because they create instant value that, again, shift the NPV of these projects up to the front end, so that you don't have to, the idea that a producer is going to take a sample, adopt a new practice, wait 5 years and take another measurement for some unknown amount of carbon from some uncertain carbon market is complete fantasy. The only way that you're going to get these projects going is if producers can understand what's going to happen. And that's the only way it can be worth measuring at scale, is if there's some kind of an impact, or you can measure negative impacts, right? And so the basic idea is that all of these steps support these carbon offset markets, supply chain marketing, climate smart commodities claims, and then management for the primary ag outputs that we all care about, like yield variability, and the accompanying ecosystem services like water quality and water management. And that was a lot, and so I'll stop there.
Hey, Chris. We're a little stretched for time now, so we're going to go straight to the next talk, and we'll have questions after all the talks. Okay.
Great.
Should I just come up there so I can?
We can all look at you as well.
All right, well, I can just get started. Hi, everyone. Thanks, Will and Carrie, for the invite, and the rest of the Expert Advisory Committee. Like Will said, I'm Cole Smith. I work as a staff research associate at UC Davis, as well as at UC A&R, the Extension Service. And so today I just want to try to shift our perspective a little bit, or broaden our perspective a little bit, to include nitrogen in the soil health and soil carbon conversation, and look at some results that we have from a field trial where we evaluated the DayCent model, the out-of-the-box DayCent model. Okay, look. So I just want to go over this connection between soil health and nutrient management, talk about what's been termed the nitrogen dilemma, look at how nitrous oxide, the connection between nitrous oxide and conservation management practices, review the DayCent model, and look at our results. So we are working on trying to connect healthy soil to nutrient management. We're looking at a shift from a standard nutrient management to what we've called a soil health focused nutrient management. And this has been called out recently as a nitrogen, that there's a nitrogen gap in this conversation. There's a nitrogen gap in that nitrogen needs must be prioritized alongside carbon. Because as many of you know, as we build soil organic matter, we're also building organic nitrogen reserves, which can be very valuable in terms of becoming plant available. But this bioavailable nitrogen then can also be lost in the same way that our synthetic applied nitrogen is, in terms of lost as trace gases or lost as leaching into the environment. So we don't need to get too deep into the sort of the frontier of soil carbon cycling, but it is important to realize that that not all soil carbon is the same. And we use this term sequestered carbon very loosely often, but as people have been working on trying to define what sequestered carbon is, sequestered carbon truly is a net gain. So if we're looking at the life cycle in terms of these different practices, we're not seeing a net gain, then that's not truly sequestered carbon, being that it's atmospheric derived and locked away in the soil. Now, not all soil carbon is the same here, and so we can look at soil carbon in a couple different ways. This is a kind of a new framework to think about soil carbon in terms of particulate organic matter carbon. This is carbon that sort of holds the same characteristics as the original input, hasn't been transformed. And then mineral associated carbon, which this carbon has been processed by the microbial community. It's transformed. It's no longer resembles its initial inputs. We don't need to debate. This is kind of still an active area. But I want to point out that these two forms of carbon, and that carbon in general has been long thought to have different turnover times and residence times in the soil, with this sort of processed carbon having a lot longer lifetime.
So if we're thinking about it in terms of soil or carbon sequestration, then we would want to think in terms of this processed carbon. And just there at the bottom right, pointing out that that processed carbon is going to require quite a bit more nitrogen than the original inputs. And this can be 2 to 4 times as much nitrogen. That's because it's constrained by that microbial community, just like your body, it requires nitrogen, a lot of nitrogen, the microbial community does as well. So this nitrogen dilemma comes in when we have these sort of large global initiatives to increase soil carbon. And if we're just thinking about increasing soil carbon, let's say this 4 part per mil, 0.4% target, we're attempting to sequester carbon or increase soil carbon at a rate of 1,200 teragrams of carbon per year, and then we use this sort of generalized C to N ratio of soil organic matter at 12. We're talking about we're going to require 100 teragrams of new nitrogen. This is a 75% increase in nitrogen inputs, based above 75% above the current level of nitrogen inputs. So we're talking about a need for a lot of new nitrogen in the system, which is puzzling, right? Because we're trying to get nitrogen reduced and out of the system. So we have a paradox, we have a dilemma here. And what is this going to do to N2O emissions? Or what is this going to, both direct and indirect N2O emissions? What is this going to do to water quality? So without this perspective on nitrogen, and if we're just focused on soil carbon, we can be really overlooking an important part of the process of increasing soil or sequestering soil carbon. So let's look at California's N2O emissions. It's a success story. We've cut N2O emissions since the year 2000 by almost half, 47%. And this is largely related to improvement in irrigation and land use changes. So we've done a great job, and specifically in very intensively managed regions of the state. So it's truly a success story here in California. But we have this issue that we were just talking about, where if we increase conservation management practices and we promote conservation management practices, it's an open question on what that will do to our gains. And so this review looked at the emissions factors. So if we establish, kind of the IPCC emissions factor of 1%, that's the percent of nitrogen applied lost as N2O. We see here in California, we actually have a wide range. Sometimes that's way under 1%, and it can be quite a bit higher than 1%. So I just want to go into reviewing a few recent meta-analysis that highlight the impact of soil health practices or conservation practices on N2O. And you can see here that they have quite a variable effect on N2O emissions. And so it's hard to say exactly what will be happening when we put these practices in place, and especially if we're combining multiple practices. But really the take home here is that it can be very site specific, climate and soil specific on what outcomes we get, as well as management. So no-till could sometimes decrease N2O, and cover crops increase N2O. And these practices are really these outcomes are really site by site, depending on management. So if we look at tillage and no-till, sorry if it's a little bit blurry because it was a PDF, but we can see that soil properties play a really important role in the outcomes related to conservation tillage. And so with the soil texture being a really important, playing a really important role in the effect on N2O emissions, as well as organic carbon. So I wanted to point that out there at the top. Soil organic carbon plays a really important role in N2O emissions. So if we're increasing soil organic carbon, we're probably going to also increase N2O. Now this is related to management strategy as well. And so depending on our irrigation, now this was a global meta looking at many studies. Here it says irrigated systems increased N2O, but I just told you that in California we reduced N2O, so take it with a grain of salt. But residue management as well. So if we are leaving residues in place, if we're leaving residues in place, this could potentially increase N2O. because we're giving a substrate to the denitrifiers. But if we're removing residue, we could reduce it. Okay, so looking at cover crops and highlighting again the soil dependency on N2O emissions related to cover crops. So as you can see again, we have clay-rich soils. These are some often also higher in organic carbon. These are related to higher N2O emissions. And when we get more coarse and sandier soils, we have lower N2O emissions, often lower carbon contents. So let's keep this in mind when we're thinking about increasing soil carbon. It's also cover crop dependent. And so the cover crop type, you know, a legume versus a non-legume, obviously that makes a lot of sense because you're fixing nitrogen into the system. That a legume would be more nitrogen rich, providing again a substrate for denitrification. And then how you're managing that cover crop can be really important, whether you're incorporating it or leaving it off the surface. Organic amendments, and this is a survey of studies across many different organic amendment types. That the fertilizer type is O organic or OS is organic and synthetic. And the blue line here to the left is the IPCC emissions factor with the range there from a little over 0 to a little under 3. And that's just to compare how wide these emission factors can end up being when they're measured under organic amendment additions. Highlighted there the CNPT kind of, I don't know, yeah, right here. That's compost application, so that's good. That's compost application is shown in this meta-analysis not to increase N2O, which is important for our study. But yeah, you can see there's a wide range, and this is also contributing to that wide range in emissions factors that was found in the review California systems. And so when we're looking at why does this matter in terms of the grower, we need to provide the growers, there's an increased demand now for the grower to be able to verify these practices and communicate them to stakeholders, as well as policymakers need to be able to verify that these practices have these outcomes that we think they have. And this is part of this system of MMRV, which is a hot topic with the Partnerships for Climate Smart Commodities, as measure, monitor, report, and verify. And so we currently lack a tight system that we are able to do that. And so there's tools out there to be able to do it. One of them, a really important tool, is the platform Comet Farm. Comet Farm serves as a refined version of the Comet Planner. The CDFA has a California-specific Comet Planner that they use to inform the Healthy Soils program. So Comet Farm gives you the ability to go in at a site level and do past and put in all these different conservation management approaches. Gives you the past outcome in terms of what you can expect from sequestered carbon or GHG emissions, but also allows you to game out some future scenarios. So this can be a really important tool to achieve a piece of this MMRV puzzle. And so the backbone of Comet Farm is DayCent. I'm just going to briefly overview it. Steve will give you a much more detailed, in-depth version of it. And so daily century model. So that's where DayCent comes from. And this is a century model. The century model is a long-term ecosystem model that's been refined over years to become a model that cycles carbon and nitrogen largely through the plant, soil, and atmospheric system, and it's recorded on a daily time step. So this gives us a great picture, high resolution picture of these nutrient fluxes, which are really important to have that resolution when we're talking about fluxes such as nitrous oxide. And this is the model is driven by submodels, which include organic matter decomposition, soil temperature and moisture, plant growth, and the atmospheric flux. So how is N2O modeled in DayCent? It's modeled based on the nitrification rate. And again, clarifying questions can be directed at Steve. And it plays or it is driven off this ammonium pool related to nitrification, but these controlling factors of soil moisture, temperature, pH, and texture are giving you the final outcome. And so DACENT treats denitrification. It calculates denitrification as a whole, including the products of N2 and N2O. And then it uses this ratio function then to dictate what the total N2O is. We don't need to get too deep into it now, but I just want to call out, in looking at the process controls on N2O in this model, the carbon is playing a really, the labile carbon, so C is standing there for labile carbon, and the model is using a soil respiration rate, carbon mineralization as that proxy for labile carbon. When we're talking about building soil carbon and increasing soil carbon, and all of these conservation practices include adding additional carbon to the soil, it's really important to realize that that the model is factoring that in terms of the total of the denitrification rate, and then also of the allocation between N2 and N2O. And so we ran a field trial because we wanted to test the out-of-the-box, we're calling it, DACENT model. We use the version of DACENT that informs the Healthy Soil Program Comet Planner tool. And we set up a replicated field, split pot field trial in the Salinas Valley. And we looked at lettuce broccoli rotations under 3 different N management scenarios. And then we mixed, and then we applied compost to some of those treatments and as a split factor at 5 tons, which is the CFA recommended rate. So sorry for it being a little blurry here, but we have the orange line is the modeled line, and the purple line is the measured line. And so our true N, 0 N, we couldn't get to that because there's quite a bit of nitrate in the groundwater there in the valley. And you can see that come out in our measured data. And so something to point out here is that the model is doing a pretty good job of capturing the events, the peaks of the events. But you can see here there's a gap where we didn't measure the N2O, but the model was telling us that there was N2O. And so if we look at the cumulative data, you can see that the model matched up really well, pretty well with our N rates. And so again, this is coming in from the irrigation water, but it matched up pretty well with our N rates. But once we added the organic amendment and compost, we started to reduce model performance there. And this is our nitrate value down to 80 centimeters. And so the orange here is sort of our continual day step for nitrate. And then our black is our measured nitrate in the field. And you can see it does pretty well here, capturing some of the peaks, but not necessarily across the whole season. And we look at it again from a cumulative standpoint. For looking at just nitrogen application rates at the surface, it does pretty well. It's, that's very impressive, matched up really well. But then once we include the compost, you can see that something's off here in the way that the model is understanding the compost, how the compost is acting in the system. And so our takeaways there are that the DACENT overestimated N2O and nitrate accumulation, this out of the box. Again, I just want to highlight that this is not calibrated to this system. It's just the CDFA model. And that our future research really needs to expand this model testing database. We need a larger data set from these specialty crop systems that are relevant to California in our ecosystems and the way that we manage these systems. So we're working on that, and they should be really long-term, multi-year. Will was highlighting some of those multi-year experiments, but a lot of times those don't include the measurement of greenhouse gases. And if we're increasing soil carbon over time, and we're not capturing the change that impact and that change over time has on GHG emissions, and we might be missing the true balance there. And so this will obviously improve, and we should continue to improve the Comet Farm tool because it's going to be important for the MMRV ability for growers and stakeholders to do MMRV. So moving forward, recommendations are, we need this, we need a much more transparency, much more standardization within our data sets. We need an agricultural data monitoring network that we are combining and joining all of these different observations, right? Sometimes we'll get just soil, or sometimes we get just greenhouse gases. More and more with Healthy Soils Program, we've been able to get those joint. But if we are losing the crop performance, the crop is often driving the nitrogen cycle as well as the carbon cycle in many ways, because it's the fixed carbon. It's the thing fixing the carbon in the system. So if we don't have this full picture with all these different components, plant, soil, and atmosphere, then it's very difficult to really get the model to tell us whether it's correct or not. And then I didn't say this also is, that I didn't go through the explanation. Sorry. So the explanation here on why the model didn't fit could be something related to the active carbon, like I was saying, and the carbon and nitrogen mineralization characteristics of the material added. So there's a new paper out that looks at carbon quality of the added organic amendment, and it looks like that has a really important role, obviously, in controlling N2O, as well as this divergence of where is the carbon going to end up, locked away for a long time or turned over. And then I just want to call out also, this could be us, right? So this could, the lack of model performance could also be on the measurement side. We're doing static chambers at mid-morning when we can, and that's a small little time window concerning the full N2O picture. And the model is really giving you that potentially full true amount. So it could be the measurement, could be the model. And with limited data, we have limited abilities to make these models work. Back to the need moving forward, so there's the MODIS data standard for plant and soil tissue analysis. We need something like that in California. We need to trust that what the data is coming from the lab is transferable and able to be ported to different platforms. And so it would be could be really important to look at something like that, a system like MODIS, to try to start to gather and make transparent and publicly available plant and soil tissue data coming from our labs throughout the state. And then this data needs to be publicly accessible, because the best way to improve models is to improve the data that you have available. And it's not necessarily a quantity question, it can be also a quality question. We need high quality data that we can trust, that's transportable and publicly available. So now is a great opportunity for us to do that. Thanks. And I just want to call out our collaborators at CSUMB. They did a lot of the in-field measurements. And if you ever measure greenhouse gases in the field, it's very hard, a lot of work. And these are organizations that have supported this work, including our grower partner at DREGO. Okay, we move on to the next.
Yeah, do we need a break?
I was just wondering if folks would like a 5 or 10 minute break to refresh your mental acuity,
Sure.
and come back and listen to you and then ask questions.
Sure.
Okay. Folks online, 5 minute break. Okay.
Alrighty, thanks a lot, and acknowledge the previous speakers. I'm going to reinforce some things that Will and Chris and Cole said already. There'll be some new things and some emphasis. Then recognize co-authors. So I'm with ARS in Fort Collins, also affiliated with Colorado State University, and work very closely with those guys, Steve-O and Ram Gurung. So a little roadmap. I'm going to start with the big picture in context of the greenhouse gas inventories and the IPCC rules and methodologies. Then look at different measuring and modeling approaches. Then really get into the kind of the guts and the architecture that we built up for the inventory and the DayCent model, and look at some testing and applications. And then probably the biggest portion of the talk is, accounting for uncertainty. We're really pushing rigorous accounting for uncertainty. So in IPC lingo, there's this tiered approach. Tier 1 is the emission factors that I think Cole referred to. Tier 3 is the process-based models, which are data intensive for both inputs and for testing the outputs. So in some parts of the world, you can't use a tier 3 approach. You don't have the data sets needed to drive the model. And tier 2 is kind of in the middle. If you have enough experimental evidence, you can come up with your own region or crop specific emission factors. And the big three biogenic gases have to be accounted for, methane, nitrous oxide, and CO2. And all the sources when it comes to the agricultural sector, all the land-based, the soil emissions from the methane, the nitrous oxide, the delta soil carbon has to be accounted, the methane from the rice system. So it's kind of a complete and managed land. Any managed land has to be included in a country like the U.S. 99% of the land base is managed land, so we're pretty much doing everything. So just the big scale contrast, the global inventory, with all the countries added up versus the U.S. greenhouse gas inventory. So I think the points here are, you look at the ag sector, it's almost 1/4 at the global scale, but only about 10% in the U.S. And the big reason for that is about half of that 1/4 at the global scale. It's CO2 from the land use change. It's from chopping down and burning the rainforest and replacing it with pasture. Versus in the U.S., if anything, we're reforesting. So that 10% in the U.S., none of that is from carbon loss. That's all N2O and methane. So to delve a little more, into the U.S., so sources and sinks. So it's like you would think, energy is the big source. That blue bar is that 10% for the ag sector that we saw in the previous. But the thing here is look at that negative, look at that land use sink. So if you think real broadly, I work for USDA. USDA includes the cropped and grazed land as well as the Forest Service. So you put those two together, that sink by the forestry growing is entirely compensating for our emissions from the ag sector. So in some sense we could say, oh, we're good, but we can still reduce that blue stripe. Then now this is taking that blue stripe and blowing it up into the different sources. So I think the main things here, you look at those two slices on the right, is the soil nitrous oxide. You put them together, it's almost half the total ag sector emissions. And then the enteric fermentation. Rice at the national scale, we're claiming only a couple percent, but in some counties and some parts of the country, that's going to be much more important. So don't really want to downplay that, but just to give you the overall sort of perspective. So measurements can be roughly divided, the bottom up and top down. So on the left, the bottom soil sampling, when you measure biomass for grain yield, that's bottom up. There's the classic chamber method, I think has been mentioned before. So the problem with, think of the chamber method, we're trying to get plot or field scale emissions. We typically do about 5 or 6 chambers, but you're covering maybe a couple square meters out of a field. And like Cole said, we're just sampling. These are deployed for about a half hour. So you're sampling a very small chunk of time and space, but we have to scale that up to the field level. So that's the limitation. But there, the top down methods, the eddy covariance towers and the tall towers there, they get around that problem. You're getting the big spatial coverage. You're getting the the temporal. So how they work is they have sensors for the different gases, say nitrous oxide, and they're sampling like on second by second, and they're also sampling horizontal and vertical wind speed. So if you know how the concentration is changing, and you know the wind velocity, you can back calculate what the surface source had to be to give you that answer. So that's why they call them atmospheric inversions. You kind of have to work backwards. So just to just to show sort of the complete tier 1 method for nitrous oxide, like Cole said, 1% is the default direct emission factor. There's organic factors. It's just based on acres. If you drain the swamp, you're going to get so many emissions per acre. Then you have the indirect, so nitrate leaching. 0.75% of the leached nitrate is going to be soon to be denitrified into N2O in the waterways and so on. So you can imagine, most countries in the world use this for their inventories because it's simple. You can imagine you just have these equations in a spreadsheet. It's pretty easy to spit out an answer. It's very transparent. I think the US, we're one of the few countries that uses a tier 3 method for our soil inventory. We actually started back in the early 2000s. So USA, world leaders, sometimes in good things. And then the overall schematic of the famous or infamous Descent model. So I think, again, Cole went through this. I don't need to spend a lot of time, but just it's a complete plant soil system model. It's driven by rainfall and your daily maximum temperature and your management, how much fertilizer you're adding, when are you adding it, etc. Does the plant growth, does the senescence and death of the plant components, that feeds into the litter pools, which decompose and go into the soil pools in the classic, 3-pool split based on the inherent turnover rates. And soil texture is a feedback. One of the assumptions is the model, as you become finer textured, you're going to have more carbon in soil because there's different decomposition steps. You're losing CO2, and the amount of CO2 that you're losing, depends on the litter quality, but also the texture. And so it's kind of accounting for the microbial growth efficiency in sort of a implicit way. We don't do the microbial community, but we account for it. And you'll see some other proxies in the model here. Well, actually, I think next slide. So Descent's complex in the sense that it's representing all these processes that lead the emissions and the plant growth, but we're not really doing the step-by-step redox reactions or say denitrification. So we have all these implied processes and proxies. So this is a good example. On the y-axis is the relative denitrification rate. So we don't literally do redox, but we use this proxy. It's driven mainly by water content. So because it's an anaerobic process, you got to be wet enough to get denitrification. But we have this kind of feedback. So if you're a finer textured soil, the assumption is the diffusion, D0 is an index of gas diffusivity. So as that diffusion rate goes down, if oxygen demand is high enough, we're using respiration as a proxy for oxygen demand. So if that's high enough and you're in a not so well aerated soil, you could get those anaerobic microsites and get some pretty serious denitrification rates at very modest water content. So this is just an example. The Descent's filled with these kind of equations. So getting into the architecture for performing the inventory, this is the big picture. We need data sets to develop the model, test the model. We have a lot of computing architecture with the different input databases. Then we compare the output with different quality control and data sets. It's just sort of like the circular thing. You need input data, run the model, you spit out the output, you compare the observations, you find out where you had model failure, you go back and try to adjust the submodels. And so hopefully through time, we're gradually getting a more accurate model. So I'm just going to go through some of the input databases. So we use the natural resources inventory for some of the key model inputs, and it's very fine spatial resolution. There's about 350,000 points in the country that we run. So from that NRI database, we can get the land use and cover, and if it's irrigated or not. But then we need to fill in, there's other things across the bottom that we need to run the model. So we use EVI, greenness index, to help inform the plant growth submodel. the weather from the University of Oregon, the NRCS soil map, that gives us our soil properties that we need, the percent sand and clay throughout the profile and bulk density, for example. Then we need the management information, and that really comes from these different surveys. So Economic Research Service, NRCS, OptiSystem satellite data that helps inform if they're growing a cover crop or not, what the tillage intensity is. So we use sales data from USGS for synthetic fertilizer. So all these are all imperfect. All these surveys, sales data, the satellite data, they're all imperfect, but you put them all together, you come up with a pretty good estimate for those management practices. When you're planting, when you're harvesting, how much fertilizer you're adding, etc. Here's a high-level product: nitrous oxide emissions, direct N2O across the country. That's like where you think we have intensive ag, lots of nitrogen inputs from fixation, synthetic fertilizer. You tend to get big N2O emissions. No surprise. And a little bit of model development. So this is nitrous oxide from field level towers in Canada. So the dots are the measurements. The lines is what DayCent says, and blue is just the simulated snowpack. And so when we first started comparing with the DayCent in Canada, especially like on that upper left, for example, the observations sometimes show bigger emissions related to spring thaw than they get in the summer induced by the fertilizer. And the model wasn't doing a very good job of accounting for those spring emissions. So we looked at different ways to represent it. Is it triggered by soil thaw, or is it triggered by snow melting? And we just played around. This is just a couple of examples, but both these sites had all these treatments, so we came up with a pretty good way to parameterize the spring thaw emissions. Kind of like Cole said, in the middle of summer, sometimes the model's doing okay, sometimes it way overestimates. So the performance of the model is certainly highly variable. And here's another relatively new model development, and then this relates to nature-based solutions. So how much how can we represent? So CRNF is the controlled release nitrogen fertilizer, like the polycoated urea, for example, versus nitrification inhibitor, and it's just compared to the standard urea, the standard synthetic fertilizer that's used where these different experiments were carried out. So we're comparing the measured versus what DayCent says during the growing season versus what DayCent says for the annual. So a few things, especially with the measurements, sometimes these enhanced efficiency fertilizers can work against you, and you actually get more N2O. But again, you look at the thick line on average, you're getting about a 20% reduction or so. And you look at the model, it's matching up pretty well with the observations during the growing season. And that's because a lot of these field sites, they only measure during the growing season. And the model shows some variability too, but at least on average, it's not too bad with both the inhibitors and the slow release. But then when you go to the whole annual, the model's showing much less effectiveness. And what's going on there, we think, is in some sense, these fertilizers, you might be reducing the peaks you get right after application, but you're delaying, you're keeping stable nitrogen in the system longer. So maybe once you get out into September or October, you're getting more N2O from those plots than compared to the standard urea. But that's kind of uncertain because there's not really enough experiments that measured the whole year. You can almost say that's a model hypothesis, and we need more data to confirm or refute that model hypothesis. But we charged forward anyhow. So we ran that version of the model with with the inhibitors and nitrification, and the slow release across the country. So I'm just showing you some results, and these are like big regions. It's just 7 or 8 of them across the country, so scaled up to that level. So showing how much you could reduce N2O. This is assuming 100% adoption. So if all the farmers switch to the nitrification inhibitor on the left, and then on the right is they're all using the inhibitor, plus they're reducing their rate by 20%. Because if these fertilizers are working as intended, you should be able to use less fertilizer without hurting your crop yield, because you're getting more, you're increasing the nitrogen use efficiency of the plants. But just take this with a grain of salt at the moment, because notice there's no error bars. We're still working on the uncertainty analysis here. So this is highly preliminary and hasn't been published. Don't get too excited. Now carbon. The uncertainty has been performed and has been published. So this is a good example. So that what the impetus of this paper was, NRCS has these different incentive programs. Set aside as the CRP program, for example. There's incentives to reduce utilities intensity. So we asked the question, what are those programs done over the years in terms of storing carbon? Then the bar is the 95% confidence interval of the model output. And so, the pessimistic way, you could say the realistic way of looking at this, in most of those practices, you're intersecting zero. It's really only the conservation tillage, but keep in mind that's only in the top 30 centimeters. So there's some evidence as you go deeper in the profile, conservation tillage doesn't store as much carbon as you think it is if you're only looking at the top 30. So there's a caveat there. But you look at set aside, if you go from annual cropping to perennial grasses, you're going to still store carbon, and we can pretty much say, there's at least a 95% probability that you are storing carbon. But cover crop, if you're doing herbicide termination compared to plowing to kill it, you're more likely to still store carbon, but still the 95% CIs are kind of ugly. But we got to be honest with you. A lot of people are going to try to discount that uncertainty, but when you're thinking of incentivizing farmers, we got to be straight up. So how do we calculate uncertainty? So there's uncertainty in the measurements, there's uncertainty in the model structure and in the parameter, the values for the parameters. Some parameters in the model are pretty well constrained by physics and chemistry, but there's a lot of uncertain parameters in the model. And the model structure itself, models are simplifications of reality. So structural uncertainty is how, sort of like that simplification, how much are you losing? How much error are you adding by simplifying reality? And we use one way, maybe I'll just go, the next slide shows these different methods. So we estimate uncertainty in two different, traditionally we've used the empirical approach, where you compare the model outputs with measurements. So measurements for delta still carbon, measurements for nitrous oxide. And it's kind of complicated, but it's not all that different than just a typical XY simulated versus observed. As your R squared goes up, your uncertainty goes down. But we, with some statistics, which is over my head, we can calculate that 95% CI. And as you have more data sets, this process becomes more rigorous. And just having more data to compare with, that tends to shrink the uncertainty bounds from the model. And then we just started on, this is Ram Gurung, using the Bayesian approach for uncertainty. So this is kind of taking those uncertain parameters, and he first does a sensitivity analysis. So you identify, maybe there's 5 or 10 uncertain parameters that a particular vector like nitrous oxide are sensitive to. And then you set up a range of prior values, for those parameters. You define a range for within that they can realistically vary. Then you draw. It's almost like Monte Carlo. You do a series of draws for those different uncertain parameters, and then you compare the model outputs with the observations. And then you can come up with a suite, the hyperparameters, you can come up with a suite of parameter values that are most consistent with the observations. And then and it's not saying one value, it's just giving you like this distribution. So you can say this is the most likely value for a specific parameter given the observational data set that you have. And then you can do model runs varying around, using like that sort of like mean and probability distribution function. You do a series of runs so you can come up with a confidence interval for your outputs. And this is fairly hot off the press. Ram just did this a couple of months ago. So he did it for the center part of the country there where a lot of the agriculture is, and it goes back to those NRI points. So use that for this Bayesian analysis. And this is comparing, so the Bayesian uncertainty, and this is for soil carbon stocks. So left and right, one's at the point level. there's, remember, 350,000 points, we're talking pretty small areas, versus on the right is the LRR level. I think there's about maybe about 20 LRR regions, so they're pretty big. But you look at the notice how the x-axis scales are different. So as you scale up, uncertainty goes down. That's been well known, reinforces that. And most of the uncertainty in both cases is due to the model structure or the model parameters. You look at the input uncertainty, you think about how much fertilizer they're adding. We know on average how much fertilizer is used, but any particular farm, there's some uncertainty. So even accounting for that, the input uncertainty is almost trivial compared to the total uncertainty. So when we have model failure, we can't blame it on not the input's good enough. So that's carbon stocks. And then this is the same thing for carbon stock changes. And this is what's really important from the incentive program, right? It's that delta SOC, are you gaining or losing? That's what the incentive program is going to be based on. But same story. And even here, it's even more emphasized that most of the error is in the model structure. But then again, scaling up, it helps a lot. And then this makes that really clear. So the site is like the points. MLRA, I think there's about 100 of them in the country. Like I said, LRR is maybe a dozen or 15. So as you go up and you aggregate in space and in time as well, your uncertainty goes way down. I mean, it makes it look like it's going way down. But as you saw in those previous figures, there's still, even at the regional level, it can still be pretty big. And this is comparing the two uncertainty methods, the Bayesian versus our traditional empirical. And it's pretty cool that they are consistent. We think the Bayesian is more rigorous and more statistically defensible, but it's good to see that they're mostly lining up. And then looking through time, so soil carbon stock changes. Yeah, this is at a big scale. And again, you might be, on average, okay, if you believe the mean, we're storing carbon. But if you think of incentivizing farmers and you account for the uncertainty discount, then it's, you're intersecting zero. So I guess it could be a little bit pessimistic, but maybe a 95% confidence interval is too rigorous. Maybe carbon markets would be willing to settle for a 65% CI, but that's for others to decide. And then I think this came up at least a little bit. It's pretty uncertain. What's optimal model complexity? We saw the really simple example of the tier one, just based on the factors. You have Descent that's kind of in the middle, and then you have DNDC is more complex than Descent. Then you even have even more complex models that do all the biochemical processes in the soil step by step, and the diffusion and phase transitions to gases. And Descent doesn't do any of that, but it's clear that DNDC is more complex than Descent. So, for example, like Cole said, for denitrification, we calculate it all in one step, and then we just slap on this N2 to N2O ratio function to divvy up how much of the denitrified N went to N2O versus N2. Versus DNDC, they actually do all the redox steps. So it does that reduction from N2O to N2, and it accounts for the microbial community to some extent, which we're not doing at all in Descent. So we think this would be a cool comparison of Descent versus DNDC to see, does that extra complexity really give you a better answer? And I think that's still an open question, because there's been comparisons between the two models, going back at least 10 or 12 years, but they've been just one or two sites at a time. So here's an example, DNDC versus Descent, and it's too limited. You can't, sometimes Descent looks better, sometimes DNDC looks better. This just isn't enough to really make a strong conclusion. So we currently have a project with the Landcraft Institute in Denmark to do a more rigorous comparison of DNDC and Descent. So we're concentrating on nitrous oxide initially, and we built up a pretty big data set from, I think we got about at least 25 sites around the world that have pretty rigorous N2O data. And so we're divided almost half and half of that data for calibration and half for independent validation. And we're going to use consistent Bayesian calibration. So you try to make it be a fair comparison. And then the idea is to compare the model outputs with that independent data and then just build an ensemble between DNDC and data census to see which is better. So does combining the models, do you fit that independent data better, or is only DayCent better, or is only DNDC better, or does it vary regional, does it vary by practice? So there's a lot of questions that this project will answer. And there's some other ways to reduce uncertainty. There's data sets that that are out there, but we don't use in the model. So USGS and some of the state water quality agencies, they sample nitrate in these watersheds and some of these streams. It's pretty intensively sampled. So you can imagine if we had that nitrate data and we compared that to the DNDC or nitrate leaching, that could help constrain the soil nitrogen cycling in the models. It's sort of analogous to how we use the EVI to constrain the plant growth. We could be harvesting this data to help constrain the nitrogen cycling. Here's another one, the NASA, the SMAP surface water. So both of these models are just one-dimensional. They're accounting for rainfall coming down. They're not accounting for any kind of overland flow. This NASA project, it gives you an idea of the surface moisture that is accounting. So we can compare the SMAP surface moisture with what DayCent or DNDC is saying, and if necessary, make some adjustments to the water model. And water is so crucial in these models that it'll be very sensitive. And then this one, just really putting things together, this idea of like multi-scale, multi-vector sampling. So we need nested sampling. The chambers have their spot because you need those to get the plot level measurements. The tall towers give you the big regional emissions. And then you need the eddy covariance to give you the mid like farmer field level emissions, and not just the nitrous oxide. We need ammonia. We need leaching, which I think we already have a lot of leaching data we haven't entirely used. We need ammonia. We need NOx. Not just the N2O gets a lot of attention, but you can imagine you could tune your model, your ensemble models to get the N2O right. But if you're not comparing with ammonia data or NOx data, you can be a factor of 10 or 20 off, and you wouldn't know. So I think this is and then this idea is catching on. And I'm going to show, so this is an example of, one aspect of that previous slide. And I can understand if some people are getting, too cynical, like, oh, the error bars intersect 0 half the time, why even bother? So just end on a little more optimistic note. So the gray is the N2O inferred by atmospheric inversions in that purple rectangle where a lot of the N2O source in the country is. So there's a series of tall towers. So they came up, this is with Cindy Evanson from UC at Boulder. So she did the inversions for that region, and the gray is the uncertainty of the N2O for that hunk of land based on the inversions. The red is the DayCent. I think this is one of the best DayCent sort of validations. We got a PNAS paper out of it. So you see in both cases, you get the spring thaw emissions. And it's like that double peak. There's probably different parts of that rectangle are melting at different times. So it's kind of cool that timing is coming out. And then in the middle of summer, you get the big peaks from the fertilizer. That's kind of easier to model. But the fact that we're getting that spring thaw, even though remember, like at the site level, it was still pretty ugly. Sometimes we were getting those peaks, sometimes we were way off. Again, it's that idea of you sort of get saved by the averages if you scale up enough. So the timing's coming out good. We're at least mostly intersecting the lower bound, but clearly the inversions are saying that we underestimate. And that's how it's been for decades. The atmospheric chemists have been accusing us of underestimating the N2O, and it used to be like a factor of 5 different. We got it down to about maybe a 50% difference. So we're making some progress. As pessimistic as some of the slides were with the soil carbon error bars, with N2O, we made some progress. And then I think Will mentioned, everything that I said is really, if you think of incentive programs, it's really pay for performance. You're using some combination of modeling it or measuring to get an environmental benefit like decreased N2O or increased carbon. So it's really all pay for performance. The other way to think is pay for practice, and it's just an example from the state of Maryland with the intent of increasing the water quality in the Chesapeake Bay. Yeah, so there's pros and cons. I think the big pro of this method is it's very transparent. It's a lot cheaper. You're not trying, and you can say like a disadvantage to pay for performance, even though you're using like these high tech models like DNDC and DayCent, that could almost lead you to believe that they're more accurate than they really are. That's why I'm pushing the uncertainty, rigorous uncertainty so much, just so people realize, yeah, these models can do anything. You can run them for any practice anywhere, but I don't necessarily have confidence in the outputs in all cases. So with some other ways out of this mess, so I think, yeah, hopefully I demonstrate that first one. The uncertainty is a function of your method. You know, how sophisticated of a model are you using? How many measurements are mixed in? It's a function of scale. It's a function of land use. Some of these land use practices, you know, like I said, if you go from row cropping to perennial, you're going to store carbon. We can say that with pretty high accuracy. But if all you do is, you know, grow a cover crop, maybe you're storing carbon, maybe you're not. And geography, meaning like where you're at, just some parts of the world, some parts of the state, some parts of the country don't have a lot of measurements. If you don't have a lot of measurements, then the models tend to have more error just because you don't have any constraints. And then, yeah, then to be optimistic, you know, at least in some cases, we know the answer. The N2O, we know what the source has to be, because you could, the atmospheric chemists, they can measure precisely how much it's increasing every year, and they know the sink strength, so you can infer what the source had to be, at least the global scale. Now, trying to divvy up that source spatially and by the different practices, that's the challenge. And then, but even smaller scales, you know, the Chesapeake Bay, they sample that for nutrients, so you know we know the answer there. There's probably some streams and lakes in California that are well monitored for nitrate and phosphorus. So if you know the answer at some scale, that can help you, you know, inform how good a job you're doing at the farm level. There's biases in the model. Your DayCent is way overly sensitive to the nitrogen inputs, you know, both the carbon and the plant growth. You know, more fully exploit these existing data sets. And everybody said it, I'll say it again, like it can't be overemphasized that we need consistent data sets that are publicly available. And I'll often just half jokingly say we should put a moratorium on collecting any new observational data until we've properly curated and analyzed the data we already have. It's kind of crazy, but USDA puts all these millions of dollars every year into collecting data, but they won't put an extra, you know, a few $100,000 a year into getting a system to make it available for the modelers and people that want to do meta-analysis and such. Yeah, sometimes we're missing inputs. You know, for cover crops, when we run the model across the country, we don't know the termination. We don't know if it's herbicide or plow termination. That, as you saw, that had a big impact on soil carbon. But there, I think we just do a 50-50 chance because we don't have any data. Yeah, need to do some more rigorous ensembles. And if we are going to do new research again, that multi-scale, multi-vector, you know, nested sampling. You know, getting all the vectors, you know, soil carbon, that gets a lot of the attention, but it's really the nitrogen. You know, the N2O is the big source in this country, and it's not just the N2O. You know, the air quality with the ammonia and the NOx, the water quality with the nitrates. So we think that can't be overemphasized. So that's it. Thank you.
Three speakers.
Three speakers, but I would suggest that anybody who has, let's start with committee members who have questions and identify to whom you pose that question, if you know, or if you want to pose it to the group, and then open it up to the public.
Well, just a comment that all three of you emphasize the need for better data systems and open data and open science practices. So I think that's great. I'd like to put a gold star on that point. I think the other question, I guess the question I had, and maybe this is, maybe it's mostly for the last Stephen, because it's more of a modeling question, but I think, you know, one of the challenges is that we can never make observations everywhere to document change. And then at some level, we have to have a tool to help us decide what practices to incentivize. That is going to help us generalize, because as Will said at the beginning here, there are very few long-term experiments that we can draw on. Really. So we're kind of pushed into this space of needing to do some sort of modeling, I think, to kind of address, we're going to have a practice-based system, like what practices to incentivize. And so I think the question I have is what is the right scale for doing that modeling? Because, and for, assessing confidence in our models. Because I think one of the challenges is there's a lot of idiosyncrasies that we can never know fully, influencing any given observation. And we also don't know, we haven't incorporated everything into any model. So at some level, I guess there's going to be an abstraction there. And I'm wondering at what scale that abstraction is most useful. Is the field scale, like we get all these observations, intensive observations from an individual field. Is that useful, or is it more useful to have sort of, like these towers that tell us that what a region is doing, trying to do the modeling at that scale?
Yeah, I think we really need both. I think the small scale data, the intensive small scale sampling is crucial for sort of model calibration and model development. But for model uncertainty analysis, then I think the big scale is more important. And so sort of related, say if you think of it as the pay for performance system, I think it's valid. I asked Ron, the statistician, so I think it's valid that you can imagine running DNDC DayCent on individual farms and use that model, the modeled output to calculate the credit they got from reducing N2O or for storing carbon. So you calculate the credit at the farm level, but you calculate the uncertainty at a much bigger scale. And Ron says that's valid, because if you were to calculate the uncertainty at a farm level, like you saw how ugly it was at the point scale with DayCent, you're going to have plus or minus 500% for most of these vectors on any particular farm. So all bets are off if you demand having uncertainty at that farm level. But if you can imagine scaling, calculating the uncertainty for the whole valley, or some reasonable geographic, and so the individual farmers get their payments, but then the uncertainty is calculated much larger. And then if you had some tall towers, and tall towers will give you the answer at that that really big regional scale. And if the if the ground, we call models like DayCent and DNDC, they're really bottom-up methods because they've been parameterized and built based on the ground level measurements. If you get the top-down and bottom-up methods agreeing, and they have entirely different assumptions, and that really increases your confidence in the answer, right? And from a global perspective, maybe it doesn't matter if you're off on individual farms, as long as you're getting the region correct. Maybe it's not so bad.
So then the uncertainty gets factored in as like a discount on
That's one way.
the incentive. Yeah.
I'd add to that. I think Mark Bradford at Yale just had a paper looking at inventory and sort of grouping individual fields, taking inventory individual scale, but then grouping those fields together to assess sort of performance over time, and this idea of these dynamic moving baselines, which are of broader scale. And so I think in the same way that you might think about a producer, an aggregator, like a Stonyfield, for example, interested in the output from their whole supply chain. That's that. I think Steve, what was it? Steve said something about the saved by the averages, right? And so you need actually far fewer samples to assess outcomes at that level against, and so the same is true with the models, right? And so you would use individual field data to build those models and to test against that larger area. And I think part of this, you know, there's this discussion of are we paying for practices? Or are we paying for performance? And I think in some areas, the models just are not performing well enough to pay for performance right now. But this is what we've done with our climate smart commodities proposal, is that we're paying for practice adoption and data collection. And so we're saying you have to do the practice adoption, and also we need some soil data to come with that. Now, obviously, you're not going to be able to do that with gas fluxes and eddy flux towers, but to the extent to which you're trying to get sort of to cover larger areas at relatively low cost, you can do that and start to better understand how those practices are impacting performance, so that you can move to a place where you're capturing what you're actually paying for. So starting to pay for practices to get the data that pay for performance, and at the same time improving the model so that you need fewer measurements and you're getting a more accurate model over time.
That's a contextual question. I mean, the charge for this committee is, where do we have advice or observations for the state relevant to its larger objectives on greenhouse gas emissions? We're not really focused at all then on the offset issue or credit issue. We're looking at what are best ways to advise the state in terms of what models are best for looking at trends at this larger level. So I'd like to ask a question from you guys relative to DASEN. Taking your point about the larger the scale. Well, California is a fairly large scale. Are there recommendations that you have, and the state is using both DASEN and DNCC, right?
Yeah.
So what recommendations might you have? Should the state be focused more on the nitrogen side rather than the carbon side? Do you discount your outcomes for carbon relative to nitrogen? If we want to improve how the state is looking at projecting forward, is there a way to combine what you know from the 30-year data sets as an observable outcome and what the model is predicting, and weight the model outcomes with that? Are there some thoughts that you have on that? So not so much at the individual farmer level, that's less the issue here, although it could be, could be an issue for when NAG is getting out a grant, but that's really not what we're talking about. I wonder if you could, all three of you guys could talk a little bit about that.
Comment on the long term. I mean, I think they're useful in that they put boundaries on, for example, so carbon and internal emissions, but they're not useful for practice because, so for example, a 30-year experiment, when we started that experiment in 1994, was based on what farmers were doing and what we thought we could include in the experimental design to try to get some more information. But within 10 years, farmers had moved on and had totally different cropping systems. Their irrigation began to change. And from the university's perspective, we didn't have enough resources to follow them. So we had to keep doing the same thing. But again, the data is useful in that we have biophysical constraint, how much carbon we could actually get into the soil over that period of time, and how much greenhouse gas emissions would make sense. Fertilizer inputs, cropping, diversity, things like that. So we have, so that's useful information. But farmers, every 15 years or so, they're doing something completely well. In California, not in the Midwest, but in California, the conversion from row crops to tree crops now is like, it's common. That's like, and if you haven't done it yet, you're pretty strange. So, yeah.
So Adam, how does that correspond to how you're dynamically updating, if you will, model projections?
Projection? Well, so, yeah, in this conversation.
Adam, you want to come be closer to the microphone? Thank you. Just for these.
So Yeah, it sounds like this conversation is mainly about inventories, actually. And yes, Lori, thank you for pointing out, we are not focused on farm scales. Our objective for 1757 is not to follow every individual farmer and say how well they're doing. We want to know on large scale, programmatically, how all California agriculture is doing in terms of carbon and nitrogen, methane, all those things. And so we do projections differently than we do the inventory. So those are two separate things. This seems like it was focused more on potentially inventory applications. I mean, for sure your presentation. The other one's about, you know, offsets and stuff that, right, that is not part of the conversation.
Right.
So for inventory, I mean, we're looking to do something totally different, which we have an RFP that just closed recently on Friday to totally overhaul how we monitor and model cropland carbon. So this hopefully will be some sort of more simplified biogeochemical model that's remotely constrained, right? So this is like the only way we could figure out that we could actually monitor what's going on geospatially, right? Because there's no appetite to telling farmers to report to us what they're doing everywhere, right? So we're trying to, you know, hire some creative scientific thinkers to make this happen. And then hopefully that model also, whatever the base model is that's used for inventory purposes, can then also be used for projection purposes in some way as well. So how we've done projections for the last scoping plan was using DayCent, partnering with Colorado State, working with all of them, and yeah, so that was the model that we used. And so in terms of, yeah, transparency, I mean, DayCent's out there, you can use it. People can, you know, it's there. And then we also have like separately, like a nitrogen, like an N2O inventory focused on a subset of agriculture, and that uses DNDC. So we'll see about that component. But anyway, that's what we have planned for modeling and monitoring cropland, carbon and nitrogen. And I should also say, you know, like, yeah, part of the issue, we can't like use the national inventory methods one for one, because just like everyone's saying, scale matters, right? And the data at the national level is like designed for the national scale, right? And so when we look at like the inputs into the national inventory, it's just not statistically sound for the state scale, like the national resources inventory, for example, which will help tell you, you know, what's going on the ground. After talking with Stephen Ogle, it's just like, yeah, it's just, we could, plus, first of all, it's not even available. You can't get it. And even if you wanted to try to go through all of the hurdles to get it, it statistically just wouldn't be useful for us. At least that was what, I haven't seen the data because I don't have access to it, but that's what the people who have access to it told me. So there's that. Yeah, anyway.
So part of what I'm hearing is the difference between where we are and fine tuning the understanding of where we are and where we want to be, and what practices will get us to where we want to be, and how well the models are going to reflect will we hit that where we want to be versus where we are. And that's where the differences in the long-term data set. So I may be hearing it wrong, but that's where I hear a great deal of the tension with that. And so the question of parameterizing in some way, shape, or form the models to reflect what the field data, the long-term field data have shown about how likely you are to get from A to B.
Yeah, I mean, and we also suffer from the same problems that everyone else does, is the lack of empirical data. And CARB is not going to create a soil monitoring system for the state of California. I mean, that's just not within our budget or our mandate or anything. So all we can do is we try to use what is out there and what's available and use remote sensing and modeling to get at what we do. So we also work with USDA and stuff and also try to pressure them to do this. But we can't. So another thing also is, flux towers. We use flux tower data as well, of course. And so, that's also another challenge, is just like tracking down all the flux tower data, because there's a lot of ag flux tower work that just doesn't go into FluxNet or Ameriflux or anything. And so you gotta, chase folks down, and that's going to be something we're also doing in the coming years. So, we suffer from those same limitations, but that's why we're trying to think about this in a new way. One thing that's interesting about my job is that, I get to model every single ecosystem in the state of California, or try to anyway. And you see like sort of the cultures of all of these different academic communities. And, so if you look like at the forest modeling community, long have they, modeled large landscapes, and so a lot of their models and data are designed for that scale. But ag is totally different, right? Ag, all of, not all, right, of course, but the majority of modeling and research is like focused on the farm scale. And that makes sense, right? We're trying to help farmers. But that's just not the problem that we have, right? Our question is on that landscape scale. And there's just not a lot of data and work that's designed to help that scale. So.
Yeah, can I sort of address that? Just because inspired by conversations with Will, I think he said a lot of the farmers are using fertigation. They said when they changed to the drip line fertigation. So fertigation is one of the practices for N2O control that works. As you saw, the slow release fertilizers, sometimes they work, sometimes they didn't. But any experiment, at least 90% of the experimental data I've seen, if you're doing the fertigation, that's about as best as you can do for mitigating your N2O. So I can imagine if you guys had a database for irrigation practices across the state, land that's irrigated and not irrigated, and if it's irrigated, are they using the drip lines, or are they using something else? Then you could imagine doing model runs, and that could identify like the areas in the state where they're not using the most optimal irrigation, and if they did, how much could the N2O be reduced?
Yeah, it's pretty clear cut. I mean, you don't even have to model it.
Yeah. You don't even need
it. You get less emissions, a fully fertilized micro irrigation system than you do from non-fertilized business flood irrigation. So you're below baseline by just converting to micro irrigation. Essentially eliminated the nitrogen.
Yeah, that's something we can say for sure. But is there still much opportunity there that do some farmers still use the flood? Or?
No. Well, there may be some grandfathered in folks who have availability to water, but not. It's getting very expensive.
Seems like here's an opportunity to overlap like your irrigated lands regulatory program. They are getting the data, they are getting the site, the crop. So we know, we're starting to get a really good picture on, what does the end look like? What does the end use look like across the state, or at least in the Central Valley and the Central Coast? So this might be a good opportunity to collaborate across agencies.
And you have to collaborate because if SGMA does kick in and say 20% of land needs to go fallow, then you're going to have loss of carbon and nitrous oxide, huge, tremendous losses back to the atmosphere.
How do you deal with that, Adam?
Which part?
This point here about it sounds like you can effectively say what your gains from reduced N2O and other emissions through fertigation. So you have a ceiling about what you can do with it. And then if we're plowing in sigma to that, I don't know how that factors or not into the kind of projections that you are doing. Is there something there that can help kind of map out the next couple of decades of likely emission scenarios?
Yeah, well, I mean, we kind of took Sigma into account in our future projections in that we changed sort of that rate of, you know, switching to orchards from annuals and, you know, having more fallow rotations built in. You know, the idea potentially is that Sigma is not going to completely take, you know, farms out of production, because the mandate is like a 10% reduction in groundwater, you know, drawdown. So it's like add in an additional fallow rotation, not necessarily take everything out of production. Anyway, so we're calling this like farm idling or whatever. But so that was like taken into account, you know, as best we could. In terms of like how we track that, you know, there's like 2 steps to this, right? It's like, first you have your inventory, hopefully that's just tracking change. Maybe you don't even have to necessarily know the practice. Maybe, you know, your remote sensing is good enough. It can like capture some sort of, you know, management change, and then you calculate a change of, you know, in the vegetation anyways. Yeah, irrigation is a little harder, but and then you attribute that change later to some sort of policy or program or something like that. So there's like, first of all, capturing and change that happens, and then there's that attribution exercise that comes next to a policy or program. Yeah, but ag is just like yeah, it's a lot harder because there's so many practices that probably just can't capture with remote sensing. You know, how do you capture, you know, pesticide application with remote sensing? You know, I just don't know, right? And also, yeah, irrigation. We have the irrigation data. That's what we use in our N2O inventory. But again, it's like it's kind of general. It's like on county level scale, which maybe is fine, but you can't necessarily match it right 1-to-1 for your crop type and your other practices that are happening. So there's like some assumptions that are made, you know, to the best of our ability. That's kind of how it's done currently.
I'll just note you have a hand up.
Matt?
Yeah, I just wanted to jump in to say that there are some ways to get some granularity as to how Sigma will hit certain regions. And this is where the social sciences come in, and where there are different, you know, attributions of rights, water rights in particular, the senior water rights that are magical and are unlimited unless the US EPA wins its lawsuit against the State Water Resources Control Board. If you took your land before 1914, you never have to cut your belt, and they won't. We went to them after 5 years of the worst drought in the advocacy community and said, you guys really going to put in 2.3 million acres of grapevines? And they said, you're in a drought. We're not in a drought. And there was nothing anybody could do because there was voluntary reductions offered. And that's like not even possible for some of these entities. So we could look at those individuals, push them over into the column, the untouchable column, where they're going to stay unless there's a major civil rights lawsuit. And then we can look at the people that don't have senior water rights, and we can assume that they and their the products they grow are the ones that are going to get a haircut. There's a lot of different social science strategies we could use to look at these farms. I think that's the difference between forests. I know there's been a lot of people in the forest compared to agriculture, but you know, this is not just a problem about science and carbon and you know, all the little life things. This is power, and the amounts of nitrogen coming out, the amounts of carbon being lost, and the amounts of biomass they're burning in my neighborhood, where we don't drink wine or grow grapes, is entirely dependent on how much water they get to throw around at their leisure based on asymmetrical civil rights. So, for the record.
So it seems like one of our approximate charges, looking at this next iteration of the natural and working climate smart strategy. And part of that has to do with inventory, but there's also these priority nature-based climate solutions. And I just pulled up the ones for croplands. It seems to me that what's emerged from the conversation here is at least one fairly simple recommendation, is that in this list of 10 or so things, most of them are about scaling up healthy soil practices for carbon storage and things like this. And what I heard, maybe this is completely wrong, but was that we're maybe near carbon saturation in many of our croplands, and that doing different things like no-till don't change the carbon status very much, but nitrous oxide emissions are huge and the big thing, and that reducing nitrogen inputs would have the biggest impact on reaching climate solutions we could have. And that is not a message that's in this set of recommendations. It's sort of hidden in this recommendation, recommendation C, which says increase water and nutrient use efficiency through climate smart irrigation systems. So that's kind of what you're talking about. That's not very explicit, and that's not very, and it's not very highlight.
And the industry's already caught it.
Well, I mean, there's still a lot of, a neighbor down the street deals with strawberry fertilization. He still says that there's huge amounts of nitrogen going into groundwater. So there's room to reduce nitrogen.
Yes.
And so this guy that's, I don't know, anything I know about agriculture is eating food, but it seems like there has to be fruitful recommendations that can be made about reducing.
Growers are going to get regulated in terms of nitrogen discharge, so they're going to be required to reduce nitrogen. Are they going to be incentivized for that reduction? They're going to be required to do climate smart practice by reducing nitrogen, but we aren't necessarily communicating in that way.
Yeah.
In the grower producer community, it's being seen as, no, we're never going to grow the crops we grow.
So I want to make sure that people on Zoom can hear you.
Oh,
You
yeah.
have a rather soft voice.
Yeah, I mean, the nitrogen discharge regulations that are coming down will require growers and will reduce greenhouse gas emissions regardless of whether we call it climate smart or not. So are we framing it and contextualizing it as climate smart practices? I think it would really change the way growers and producers accept some of this. It's more of a positive thing to say that it's a climate smart practice to reduce and discharge.
One of the things that I'm hearing here is the intersection between the ARB's work and CNRA's work. And so what I'm hearing very clearly is there are certain limits to what the modeling. We know that there's certain limits to what can be hit in terms of the gains in agriculture through changing the nitrogen emissions. There's that fertigation issue is something that you can project out. How far can you go there? But then the question of what is the climate smart land strategy recommending as the primary, secondary, tertiary levels of action that will help us get to that envelope the most quickly. One of the things that we are talking about in the modeling here is one of the recommendations out of the committee was to establish these fringe plantings. Now that was more from a larger climate lens. It's not really so much about carbon as it is about climate adaptation, water, biodiversity, cleaner, better water, a variety of other parameters that were in our report. And so since Adam is here and Amanda is not, we get to ask Adam a question, and then when Amanda comes back, which we hope will be fairly soon because we want to switch over to the.
Yeah, you can also ask me a question. If helpful.
She volunteered to talk about a couple of things with the committee, but is there a relationship here, Adam, between what you're focused on relative to modeling and inventory and reporting on how well the state is doing and establishing a projection for the total, kind of the maximum that the state can achieve, and the recommendations of the climate smart land strategy about what are the most important near-term activities that we can engage in?
Yeah, For sure. Well, first of all, point of clarity, our objective is not to maximize the amount of carbon in our ecosystems or,
No, I wasn't trying to say that, so please don't misunderstand me.
okay, because
I was
yeah, you're just saying projecting the potential
For
anyways.
reduction of greenhouse gas emissions.
Right,
And
okay,
in
yeah,
particular, nitrogen, which has been a big focus of today.
right, yeah.
We seem to understand there's an outer envelope.
Yeah, right. Okay, so you're right. So how it worked before, at least, with the climate smart strategy and scoping plan. Climate smart strategy came out first, right? And it was really assessing, really like, what are all the actions people want to see? Like, regardless of, you know, the carbon impact that it will have. There's all sorts of things in there, right? There's like beaver, you know, re-establishment, things like
And
that.
we're less focused on carbon.
Yeah,
Right.
and I'll say that, and that's one thing I wanted to respond to you is some of the priority nature-based solutions you see in the strategy, the charge is really co-equal mitigation and adaptation. So we're not looking just at what are the practices that are going to get us to carbon neutrality, although that's, you know, 50% of our goal here. It's also building resilience of these systems.
Yeah. And then, you know, creating the targets and modeling things into the future, you know, there's this huge scenario development exercise that takes up like half of our, you know, scoping plan time, which is like going out and getting like these visions of the future that we want, right, for all of our ecosystems, and then modeling, and then like putting practices to those visions that we think will, you know, best get us to whatever that end objective is. And so, you know, for the scoping plan, the overall, you know, objective is healthy and resilient ecosystems and communities. That was just the priority, not necessarily maximizing emissions reductions or carbon stocks, right? However, I should say, you know, it is clear in the scoping plan, from the scoping plan modeling and what we say in terms of croplands, especially annual croplands, nitrogen is where all the action is at for climate mitigation. Like, that's just clear. I mean, that comes out in the scoping plan. That's in part of that's in our modeling. That's in the data. That's known to the state. It's known to CBFA. So that is not like a mystery, right? We need to reduce those N2O emissions for sure. So yeah, I guess that's how those two things relate. Is so like we create these visions of the future, and then we look to, you know, the climate smart strategy for all the practices and figure out which ones should go where and model those out.
So fundamentally, it sounds like they're side-by-side exercises. And so
strategies-
that's the issue that I think a number of us were kind of teasing apart here.
Yeah, I think that at least in the first iteration, which is this is only the second time we're doing the strategy, is it comes first, identifies these practices. Adam then takes these practices and where he can, where they're modelable, pulls them in. And obviously some of them aren't, like beaver introduction.
Some of them aren't like the French blankets, you know, there are ways to look at that. But-
Yeah,
So
yeah, it's a mix, yeah.
No, that's, yeah, that's fine. That's true.
The idea. Go ahead.
Oh.
Yeah. Petros and borders, yeah. Are there other questions from folks, members of the committee online? The colors are such that it's hard to see a hand raise. Do you guys see anything?
Yes.
Do we want to open this to the public?
Sure, and that side. Yeah. Excellent.
Oh, it's going back. Sorry.
So for those who are
There you go.
online who, members of the public, this is a great time to ask questions and make comments.
Yeah, Tom. If you want to come off mute.
Thank you. Appreciate the opportunity. I think I'm going to take my camera on here perhaps too. Hi. Fascinating conversation today. Appreciate the opportunity to comment now. I'm Tom Collin. I'm in Sonoma Valley. and have followed this group's work a little bit in the past. And just for context, I worked for many years in the building energy efficiency modeling area, and our work in evaluation, measurement, and verification was the foundation for what became essentially $1 billion or more a year of subsidies for driving state level investments in building energy efficiency and demand side management. So there's a lot of interesting parallels that I see as this community is trying to figure out how to use modeling and calibrated modeling to justify public investments, because we know that's what's going to drive incentives and practice change. And in retrospect, the challenges that we had in the building energy world, much simpler, because we're measuring something fairly tangible and measurable. Whereas here, you're trying to capture these dynamic soil processes. So it's an order or possibly several orders of magnitude more complex to grapple with. And I'm concerned about some of the comments I heard today. While I agree with a lot of them, for one, because we did look at Bayesian statistics, and we certainly relied on Bayesian statistics, but the idea of relaxing the confidence level, I don't think that solves the problem. It just expands your error bound, and you end up overlapping that 0 point even more if you do that. So I would discount that approach. I think the ultimate question of trust in the whole process is what's going to drive the policy change and to have there be incentives available. And my takeaway from today is that we just don't have that right now in the below ground on farm area. And I think that's the takeaway from your discussion after the presentations, is that nitrogen needs to be the primary focus, and maybe carbon takes a back seat until we can do more of this more granular modeling. And I'm encouraged to hear about some of the newer data sets and the other models that might be available beyond DayCent. Let's see, one other comment. This is a question for the group. It seems to me that much of what you're talking about in agriculture today should also theoretically apply to below ground carbon soil monitoring in forests. And I'd hope that there might be at least some answer to that from my perspective, for those of us who are looking at this holistically. One of the problems that we saw in the building world is that, and this is to Matt Holmes's point, that once you have a very plausible logic model for how your theory of change and how your incentives are driving the markets to change, you end up with distortions created by market players who have different incentives, and you end up with groups that want to assert the industrial consumers versus the residential consumers and all of that. So I'm curious to hear how what you've learned in agriculture as part of today's presentation might apply to the concepts in the forest sector as well. So I appreciate the opportunity to comment. Thank you again.
Sure, how to answer that.
I think one of the biggest differences is you don't have the annual disturbance in soils and forests, and you don't have the kind of soil profile disturbance in forests that's the same. But certainly the clarity of labile versus stable carbon or mineral soil carbon that is related. Any other comments in that regard?
To respond to the uncertainty, that's stuff on your presentation, but in the Bayesian context, the uncertainty is considered a credible interval, not a confidence interval. So really, it's representative of a state of knowledge. It's not a relaxation.
Are there other questions?
Well,
Here.
yeah. I'd
I
love,
just wanna-
Chris Covey here. I would love to just respond to a couple of the questions that he asked, if that's okay. I think one is forestry. You know, there are changes that are documented when you clear a forest and buildup of carbon over time, and those appear significant, and they appear to vary with soil texture. For example, heavy clay soils holding on to carbon more readily than sandy soils, and so it's important. I think one of the reasons you've not seen that incorporated into existing protocols for measuring, monitoring, and verifying carbon sequestration in forest systems is because it's just really hard to measure and scale carbon in forest systems. And so dealing with things like roots and rocks and heavy organic horizons and vole holes when you go to scale soil volume, and the actual physical, having tried to apply the same techniques that we're using to measure and monitor soils in agriculture into a forest ecosystem, it has a whole other set of challenges. There is a group at the U.S. Forest Service that is working on addressing those challenges alongside with the groups, from NRCS that are looking at national soil carbon inventory, but it's really hard. I also think that, that point about the order of magnitude more difficult challenge of modeling these really complex dynamic systems is real. And that's the point of continuing to think about getting data that can support that modeling effort, both support it from a model construction, is initialization standpoint, but also support it from, I think, that really important point about trust. And you can take whatever is off the shelf and say, oh, we took Descent because it was the best thing available, and then we're hoping that someone is going to build a next better model for California agriculture. But of course, that is dependent on someone doing that thing. And wouldn't it be great if the state were thinking about how we are actively, or how you all are actively improving models for California agriculture to decrease those uncertainties and increase the applicability of the model in some kind of an iterative process. So I think he's right, it's a huge challenge, right?
Thanks, Chris. Are there other questions or comments from the public at this juncture? If not, we will move on to the next item on the agenda.
Can I ask Chris a question that's only slightly off topic?
If it's off topic, let me suggest that you do an off-channel conversation.
I'll get.
Laura, did you have a comment that's directly related here?
I was just wondering if we were talking at all about flooded, or not flooded, but like methane. We were going to have any discussion of methane flux in rice systems, for example.
Systems.
Yeah.
Really haven't just that well.
And people on Zoom here, William?
Sorry, can you hear me? Rice and methane is one positive thing for California is that our emissions of methane in California are lower than the global average. And the reason for that is that our rice production is productivity of our rice is higher than areas. And there are hypotheses to explain that is that, okay, so the plant is allocating a lot of carbon to grain production, and therefore leaving less carbon for methanogens to mine. But that's primarily been the source. So overall, methane emissions from rice in California are about 1% of total emissions. So you have to
Yeah, in terms of like CO2 equivalents on 100-year time scale.
And there's not many practices. There are practices to reduce methane. You can do sort of flood drain approaches. drain approach can almost eliminate 75% of methane emissions. It does impact some growers' yields, and so growers are not happy to do that all the time. I have a USDA project right now showing that fish can eliminate methane.
That's the study I wanted to talk about. It's really, really interesting.
But that's kind of hard to scale. I mean, how to, and water availability would be a problem to scale it to.
Does everybody know what he's talking about? This is integrating salmon rearing
Right.
with rice fields. And so it provides a safe habitat for salmon and enables them to gain the weight they need to get out to sea successfully. And the double benefit is virtually
methane reduction, which is, there was only a few reports in the literature, so we wrote a USDA proposal, we got funding it. And sure enough, our first year of data showed, yeah, you get significant methane reduction. So there are these practices that can be developed over time. And try to be sort of holistic of how did the ecosystem work before? Could we take parts of that and put it into our intensive agriculture and get the same similar results?
Well, why don't we move to the next part of our agenda since Amanda is here?
We do have a hand.
No,
Oh, I'm sorry. Okay.
Matt?
Yeah, I think that's me. I'll just be real quick. The salmon and the rice story are interesting for some social science reasons I'll share with you all as well. For starters, the North Valley's certainly done a much better job at protecting the commons than the South Valley has. So Sacramento Valley has worked together and its water pours out, remarkably better than the water we get from the San Joaquin here in Stockton. History has shown up and working together should matter when making recommendations, but also, the Delta is subsiding because our ranchers can't afford to pay their reclamation fees. So they're plowing up three crops of corn for silage for pigs, and they're dissolving their islands by 2 inches a year. They're 28 feet below sea level. Those islands could be retooled for rice if it's flushed out enough, and that rice will at least hold ground. Not to mention bringing in, bringing that ocean nitrogen back up into the forest with salmon would be a worthy pursuit, regardless of global climate instability. Lots of wins there.
That's super helpful. Thank you. Are there other hands that I can't see? Sorry, apologies, but the little yellow hand is really hard to see from over here. Okay. So one of the things we have asked for as an update, moving on to the next agenda item, which is kind of our any other business element. I think many of us are aware that the state of California has had some pretty significant budget reductions. And quite a few of those have hit the conservation space and the nature-based solutions space, about $1 billion worth. So we were wondering if we could hear a little bit from you about that, if you'd be willing to distribute to committee members what those reductions are. They've already been recommended.
So as you guys know, the governor puts out a proposal in January, then we talk with people and the legislature, and then it gets revised in May. And so I guess the question is, I could help look at sort of where things stood in terms of the governor's January budget, or we could do that after May revise.
I think it'd be helpful, frankly, if you were able to do both. We were able to understand what has been recommended and see the impact of that relative to the types of recommendations that the committee has been making and the Climate Smart Plan strategy as it exists today, knowing that you will be giving a revision to us in June or July. But I think it would be great if you could help inform people now, because we have a couple months to go on the revise.
So just to confirm, the interest is understanding the total amount of nature-based solutions funding put forward in the governor's budget.
That would be super helpful. And then I think a number of people are also tracking the notion of the climate bond, which will be coming forward. So one reason to help people understand where the reductions have already been proposed, and there are likely to be more reductions in the May revise, frankly, than fewer reductions. But to help understand the alignment between what may be in the Bond Act, or what people might want to see in the Bond Act, to align the Bond Act with the Climate Smart Land recommendation, the strategy, and with where programs stand today. So it's putting those, that's giving committee members more of information to understand the potential trajectory of some of the kinds of recommendations that are being made in the near term, recognizing that every year's budget is about as variable as every year's weather. Sometimes.
That, but also I would just like to share, I mean, I think if you're gonna use the information, the budget information to understand, current levels of investment, and thinking about, recommendations for.
It's just a factor.
But I guess what I want to flag is you mentioned, using this information to inform a bond, to inform the strategy, and that sequencing is not going to work.
No, I'm saying it helps us all understand potential alignments in the future. What needs the most attention? Exactly. I understand you may not approach it that way, but it's part of the larger package. And then can you share any updates with people relative to timing? You're still targeting June or July on the draft?
Yep, no changes.
Lori,
I'm sorry.
I just had a comment on alignment real quick, because I really appreciate that. But I think understanding the way what people are willing to fund does make a lot of sense. I'd like to ask if anybody works at the Natural Resources Agency that's seen anything compelling come out of this expert advisory group, and if there have been consultations with specialists or project managers that I can tell us we're on a wrong track for a reason, as opposed to us doing this really isolated academic ritual. I mean, I want to see some feedback from staff and expertise and legal and guidance. I feel like we're here for a reason.
So the recommendations that were put forward by the committee went out to all of the agencies that hold these targets together. We looked at them very carefully in sort of developing and drafting the targets. So I absolutely would say that the work of this committee is being considered and informing our work, which is exactly what we hoped this sort of setup would do. I guess I'm not sure I understood your second point, but this committee was created because of the expertise of the people who are on it. And so, we're not going to evaluate your expertise. We are going to take it for what it is, which is guidance to us.
Oh yeah, no, I'm sorry. Maybe I can restate. There's a lot of smart people in here researching complex things, and if they were researching specific things that were plausible within the doability of the resources agency, I don't know, maybe we can take advantage of the last few months that we have here to get something really pragmatic and doable. That's, it won't be perfect, right?
Yeah, I mean, I think, so I will say that we did get questions from people who were like, wait, why did they recommend this? Because we're already doing that. Or did they, consider blah, blah, blah. And of course we didn't answer those. But our hope would be, if you guys are amenable, is to, once these targets are released, which is going to happen very soon, we would love to identify some of the sort of core questions that emerge, not every single one, but ones that emerged enough that we were like, okay, that's a question we might want to actually follow up with the committee on, just to go through those and to give people the opportunity to understand more or get more information or anything like that. So that's something that we would be very grateful for the opportunity to do, but it's not critical given you have a busy agenda this year, and I know you've got a lot to do. So
Okay, thank you for that. That's refreshing. And Lori, maybe I'll talk to you about steps forward offline, and you can advise me otherwise.
Right, one of the areas, just going back to the conversation about budget, bonds, investments, moving the needle, is that within the climate smart land strategy, there's definitely the room to recommend things where we know the trends are good. And that was one of the charges that the committee adopted from day one, was where do we have known proven things where we've got that kind of data. And so that vehicle is a great vehicle for that, for the long-term kinds of initiatives. Or longer. 5 years is a long time in state government. 10 years is an even longer time. So those are, I think that is also part of the alignment, and tears back to what Matt is saying as well. Whereas the discussion about the modeling and monitoring and the timeliness of data and the interannual variation in data and so on, that's kind of more in a different bucket for us. Are there any other questions for Amanda before we move beyond this?
We don't, so we should thank the speakers.
We should thank the speakers, let them go, but I want everybody to stay on for, I have a couple of, we have some scheduling questions for the committee members, but
Two speakers are me, so they have to stay.
you've got to stay, but I would say let's give you a
Chris,
significant round of
thank you so much for
Thanks, guys.
Hey, thanks. Fun to be with you all. Enjoy the rest of this meeting and what I'm sure will be a long grinding process to a fruitful conclusion.
Thank you.
Thanks, Chris. Fast content. I like it.
So in terms of our next meetings, there was the question that was brought up earlier, did we want to have a meeting in Riverside? Do we want to have external meetings, field meetings? And so this was in the context of last year, we want to meet out in the field, and we want to do a field trip. With the current budget situation, there's not the funding to do that in terms of incorporating a field trip, as I understand it. However, the committee could meet in person at the ARB facility in Riverside to enable an opportunity for more members of the public in Southern California to potentially attend that, to give more diversity of exposure for the work of the committee. So Adam has identified we could meet there. Riverside is probably better in May or November than in July or September, just given the general timing. But is there any interest on the committee's part, given the fact that there's not the funding to do a field trip element of it, but it would give greater exposure to members of the public in Southern California? And that is an interest in the committee in doing that, because there's certain logistics that the state would have to undertake for that we need to know about. So, members of the committee, please give your point of view.
I would say that 85% of the visitors are online, which doesn't make any difference in where they are. And that's historically the case. There's been a few people show up, and
The first meeting was different.
but then those people were generally from NGOs and lobbying the state, and so they also might not particularly be local. And so I'm not sure that I'd be convinced that we're disenfranchising the parts of the state. But that's
Any other thoughts from Matt? You have your hand up?
Yeah, we went there with the Jack, and it's a pretty fancy building. It's got cool tools in it. It's got some cool public art. I'm not exactly sure how it relates to our priority here, natural and working lands. It's a cool building, but I just as soon take you all to the Delta Science Center and show you everything that's going to go away, or we got an agricultural center here in Stockton. The place that is, well, I guess this is for everything as well, but when we talked at the beginning of the meeting about how we're really looking at some strategies that are going to change over time, and that there really is a phase 1 and a phase 2, and that hopefully in phase 1 we can do the right thing and protect the people that are most vulnerable. I don't see how Riverside would serve that, you know, that purpose. You know, CARB, again, this committee was spun out of CARB for a reason. You know, this is still new territory for them. My 2 cents. I love going there. Great sushi, great Korean too, right there.
Yeah. I think from what I understand, it's really a matter of budgetary constraint that it has to be in a CARB building, and just for travel for state personnel, it's limited as to where we can go, and there's no travel for outside of.
Have we mapped participants?
Either of you want to respond to this? You're in a better position than I am.
What's the question?
We have not mapped where the participants who are calling in are from. We have not asked them to report. Members of the public, we have not asked them to give their locations, just the committee. The field trip issue is also a bag and keying issue. So in addition to funding, we need to be in a public government building for bag and keying.
If we do think about Riverside, I will say that it did seem that the people who were from that area tend to be more focused on deserts and chaparral, and so that should be the focus of the meeting. That might.
Well, if we were to do a, sorry.
And you broke up on that.
Sorry, I was just alluding if we could pull in the desert constituency by using the Riverside location. I think that would be great. I just know it's a long freeway, but that would make sense then. Otherwise, you'd normally go to Riverside to fight warehouses.
Well, could we get a kind of a flash polling of the committee members if there's a sense that it would be desirable to do something in Riverside, or are you just as happy to stay in Sacramento as a physical locus for the meeting?
If we were to Riverside, would be like a workshop, like trying to write reports.
I think it's just a
See this just in Riverside.
I mean, it'd be fine. If we could get more people involved, then yes. If not, then makes sense.
We have a couple of hands up online, but I can't see who the names are.
Yeah, John.
Yeah, I would just say I'd prefer, I mean, it seems like an enormous effort to go to Riverside for the whole group. So I would say I'd prefer to continue in Sacramento and just encourage public participation through the online, because it's been reasonably good.
Mario.
I agree with John. I was going to say the same thing. We should do whatever reduces carbon the most. I'm also not the right person to say this because I can't attend the May 30th meeting. I'm not sure if the in-person meeting is being proposed for all of the dates that we're looking at, or just May 30th. I thought it was the 30th, but getting the most folks is the best thing to do. And it seems like the online participation of the public has been pretty good up until now, in my opinion.
Okay. Any other comments from board members online, Alyssa?
No, I agree that I think it makes, unless there was some group of people that we were intentionally planning on engaging in Riverside, I agree with John and others.
Debbie, is Debbie still with us?
Yes, and Matt has his hand up.
Okay.
Yeah, I was just gonna say, if there's any sort of ambivalence about this issue, like, you know, if there's, well, first off, it sounds like Natural Resources Agency doesn't have any facilities that we could visit that are relevant to natural and working lands, that only CARB facilities are eligible. I'm pretty sure I can get Delta Protection Council, National Park Service, Fish and Wildlife Service, people with relevant places to our study to host a meeting. And we do these. Comply with Bagley King. But yeah, I want to increase participation. I'll just say the online participation is its own curated population, and that nothing's better than going to meet people where they're at, somewhere near a shoreline. And that if there's, you know, if it's 50-50 one way or another, it's perfectly appropriate to rely on statistics as to who the most vulnerable populations in California are to the failure to address natural and working lands, and that taking this committee to somewhere where y'all can meet some folks that are going to get hit first with all sorts of things, whether it's sea level rise, you know, asthma and wildfires and industrial pollution on top of that. I think it's enlightening. But of course, I understand the constraints for the record.
So, Bessie and Matt,
Debbie also has her hand up.
right, but can we just clarify Matt's question? Because Matt is saying, or was posing the question of, could we utilize a different entity's facilities? And what I had heard from you earlier was, no, it had to be for the staff to travel, it had to be to an ARP facility. And so I may be entirely wrong with that, but he was opening up a different question, and maybe I can't answer that.
I mean, the meeting clearly doesn't have to be in a CARB facility or Cali facility. We're here at CNRA. But, you know, if we impose ourselves on another agency, I'll leave that question up to Amanda, CNRA. So.
Yeah, I mean, I think Plessy was clear, as long as it's a government building where the public can come in and join us, you know, that's the parameter.
Yeah, we just need to stay at, like, we can't go on
Do a field trip.
can't do a field trip where the committee is
Right.
in a space that's not necessarily noted, you know, there's the banking issues there, but it could be a publicly accessible government building.
Yeah.
Whether it
Yeah, we
be a like, Riverside or somewhere in Stockton or wherever.
Yeah, I was going to share that we did a number of these with the Delta Protection Commission for the National Heritage Area, and held local meetings that were duly noticed. There's a really great facility in the East Bay Regional Park District, which is why I asked about mapping participants, like where do most of us live and where does staff live? This place is day travel for state employees to get to Antioch. And it's a public facility that hosts the public, you know, 24/7. So there's ways to get it done.
What I'm
Sorry?
hearing is that we're asking staff to identify if there's a facility. Is there a facility you'd like staff to identify that we should use for one of these upcoming meetings?
Well, I guess my first question is, Lori, I think it starts before that with, does the expert advisory committee feel like it's necessary to go be on site? You know, I don't have the same relationship to this work as y'all do. You know, you probably don't need to go to Antioch and stand by the shoreline to revise, you know, delta and estuary projections.
But I think what we're hearing is that if we went to Antioch, we could go into the public facility, but we couldn't stand by the shore. Because that would be
You
bad.
can do both. You can do both. Yeah, there's really great public agencies.
I think
We can't as a group.
we can't as a group.
We could do it for under quorum. A group could go out under quorum.
The meeting could end and people could disperse.
Because how this,
The
because of
entire
how this-
facility is ADA.
yeah, but because of how this committee is structured, where some people are in person and some people are virtual, we have to have that virtual component for it to be Bagley King, you know, whatever.
If we did all in
Fine.
person, we could maybe.
If we did it
walk
all in
outside.
person and then all, you know, there was no virtual component where then the public could also go out with us and all that, then I guess that probably could work. I mean, we'd have to check with the lawyer. That sounds right.
Okay, yeah, I feel the tension on that. Well, I think it's worth thinking about, but only if you guys think it's relevant. I think before anybody asked the agency, just because I brought up that I was on the DPC, that I was on something with the DPC, I think we should think about whether or not it's relevant to our recommendations.
So I think Debbie has her hand up. Let's benchmark this, and we're going to ask the state to help us out with the resolution, because initially there had been a real desire to have meetings in more than just in Sacramento, and then because of the budget issue and a variety and the hybrid structuring and so on, that has changed. So let's come back to that with the state. And there's Debbie, and is there one more besides Debbie?
No.
Debbie, please.
Okay, hey guys, can you hear me?
Yes.
Yep.
Okay, great. And I don't know if my comment is relevant at this point, but I was just going to comment on, having the meeting elsewhere. And I kind of appreciate both things that I've been hearing, one being kind of reaching a new and different audience and how important that is. And then also how it might be difficult for a lot of people to travel down there and carbon footprint. So I guess I don't have a strong feeling about it, but I think it could be interesting to go down there. But if I remember correctly, it was the May meeting that was going on ABB down there, and I also am not available to join that meeting no matter where it is. So that's all.
I don't think there's a constraint that it's May.
That was the date we had originally been targeting, but we could change to a different date.
I don't care.
Okay.
Yeah, we just need enough lead time to reserve rooms like this.
Okay.
And in fact, if we're gonna try to go somewhere that's not like under our, immediate control, then I would recommend later, which because it would take a lot of coordination.
But there is enough of a budget to cover staff to travel to there? Because that was the other
I mean, it depends on
question
where it
that
is.
we heard.
Depends on where it is.
Yeah, we need to check on that, actually. I think you guys are aware that there's a lot of scrutiny on the budget right now, so I think it's best that we just double check. That's somewhere within California would be acceptable. And I concur with Adam's point that definitely helpful to think through the meeting or meetings that you guys would want to do something in another location. And give us a little lead time to get that stuff set up.
Yeah, absolutely. We do, if you look at the screen. Yeah.
They should. You don't have, they weren't sent to you?
Oh, there it is.
Okay.
Yeah.
It's the very end of it.
One of the things I'd like to just bring up that agriculture was kind enough to be the pilot for these deeper dive conversations, and in looking at going forward, we'll probably need to have these conversations be a little tighter in order to cover the other key areas. Some of the conversation, for example, is that we're not entirely sure what we could contribute further on the desert conversation there, but there are a number of suggestions about maybe there's a conversation about what kinds of benefit and limitations do we have from increased remote sensing in terms of inventory and monitoring. What are the pluses and minuses to that as a component of going forward? But in terms of looking at this as helping consolidate or prioritize recommendations around the climate smart land strategy, looking at forests, wetlands, grasslands, shrublands, and pulling together some fairly tight expert discussions on that, maybe having 2 discussions per meeting as opposed to 1. And given that Amanda is indicating that I'm understanding that we probably wouldn't have had the draft climate smart land strategy with sufficient time to give much feedback at July 11th, but we
Yeah.
absolutely would for September.
Yeah, I think what we talked about was you guys working throughout the year to kind of develop these barriers and solutions.
Well, most of them are actually in our report already.
Yes,
Yeah,
we're
sorry.
definitely tracking that,
Yeah.
100%. So anything that, is in addition to that. And then, yes, looking at the draft and having that as another sort of opportunity to develop recommendations. And I can't remember what timeframe we said, but whatever we said when we first discussed this, I think it might have been.
Yeah, we were originally
September.
targeting like June and July for public comment. Around depends on exactly when in June that the draft goes out. And having it sometime, having input, you all's input on the draft. Sometime not too far after that would be
Well, our
helpful.
next meeting is September 12th. So that would probably be the meeting at which that could best be targeted. And I'm simply asking this from the point of view of trying to stack some of these presentations for May and July. There might be a preliminary conversation in July, just very superficial, but then September would be a key focus for that.
But also just to flag, like the recommendations coming from you guys does not need to be an agenda item. It could be just like, in other words, we don't need to take time in your meeting schedule to do anything. Maybe some recommendations. It's more just a matter of you getting them to us in time for us to build them into the final. So don't worry about that in terms of an agenda item.
And
Unless
just
you
that,
want to.
Well,
That's your.
You would certainly be able to have individual feedback from people, but as a committee, that probably wouldn't happen unless it were on the agenda.
What was the last one? Was it?
We went through every section of the report in committee.
I'm so sorry. I guess what I'm trying to say is, if you're concerned about agenda time, just like last year when you guys submitted the recommendations on the targets, like in writing to us,
Okay,
it wasn't like discussed as an agenda item.
understood.
And that's what I was just saying is parallel this year. So if you're like thinking about how you're gonna stack the various landscapes in the meetings on the schedule, what I'm just saying is, just like last year, the recommendations that we get from you are all we need to keep our work chugging. And it doesn't need to interrupt your schedule for these like landscape specific experts to come in and speak to you all.
There's a Venn diagram here. We'll okay.
I'll just emphasize that we are very much tracking the recommendations from last year and their applicability.
Yeah.
To the strategy, and there's a lot of good input on that, and it's not, you guys don't necessarily need to just rehash all of that, because we're tracking all of that.
Excellent.
Yeah, I have just a request, I suppose, as we move forward with like the modeling discussions. So when you determine, what topic will be covered for whatever meeting, maybe it's like 2 people who are leading that landscape. Maybe we could have a discussion, because I have very specific needs and questions and things I would like folks to talk about. And I have also, from hearing from the public for so long, things I know that the public wants to hear about. And so I would like to have you all address that, because, people don't trust me all the time with everything that I say. So it'd be good to have a third party expert people say some things, yeah. So anyway, maybe.
Point taken.
Yeah.
Okay. Well, we're going to give everybody back 18 minutes of time. And thank you all online. It's much harder to participate online than it is in person. So we really are looking for
I think we need to do public comment on this one.
Yeah.
don't we?
on the agenda.
I think so.
Oh, okay.
But
Public comment on the
also, so no meeting in Riverside on the 30th. Was that determined?
It does
We
seem like
make a
that would be.
move to, I think
I'm happy to make a move.
where we landed was that there would be some input as to potential locations that was discussed with you all. You all found out whether or not you could have remote locations because of your budget and where.
But we're also requesting that that happen later.
Yeah,
Maybe.
and we're good with that. I think everybody's good with that.
Okay, so May will be here.
Here.
Okay, good. Thank you.
All right, can I just throw one more thing on the agenda? You were talking about pairing things up, and I wasn't sure if we have like a draft set of order of things.
We do not.
A little bit of a plan. Do we need to talk through that, or do you?
We
wanna
have
just-
recommendations. Everybody is kind of in a different state of evolution as to recommending people to
Yeah.
talk.
I
So-
feel like you might be the only one who knows across the board which ones are further along and which ones are nowhere. And need to
From
get
where
in
I
here.
sit, yeah, I don't have a plan. I'm
Okay.
happy to send out some thoughts around that, but I do not have a plan. I know that the blue carbon wetlands people have a group that they are set to recommend. And so John and Melissa have put that together, which is terrific. So they're ready to go, but we don't know whether or not their speakers are ready to align with the dates that we have. So that's another piece of this kind of little mix and match. So we'll follow up and get your help in making it happen. Anything else before we move to public comment and the close of the meeting? This is where Jen Phillips would so kindly say, going once.
Any public comment?
Right. Now you all get back 16 minutes. Thank you so much.
Bye, everybody.
Yeah.
The answer.
Thanks, everybody.
Thank you.